Okay. Thanks, Ken, for that. Appreciate you for hosting and organizing this event. So my name is Luis Cuevas. I'll be the moderator for this mini conference. My role in this whole organization is I'm currently the new collegiate chair for the AIAA LALV professional chapter here in the SoCal area. So a little bit about me. I actually attended this event twice in the past when I was a student at UNLV. This event was great. There was so much networking, a lot of valuable information. The panels were amazing. I got a lot of insight into, my future and some of the goals I wanted to achieve after graduating college. But anyways, so again, I am currently a structural design engineer at Lockheed Martin Skunk Works. I've been there for almost 3 years now. Like I mentioned, I went to the University of Nevada, Las Vegas. I studied mechanical engineering there. And while I was at UNLV, I got involved heavily with AIAA. AIAA has been so valuable to me. I've made many lifelong friends through that organization. And being from UNLV and not having an aerospace engineering field or program, it was really valuable. Being a part of AIAA was really valuable to me because it was my first exposure to anything aero, really. While I was there, we worked on RC airplanes, DBF, which is the national competition, design, build, fly. We also worked on 3D printed, this 3D printed aircraft competition hosted out of Texas, Arlington. So that was exciting times. But I owe a lot to this organization, and it's a wealth of resources, it's a wealth of knowledge. So I'm glad everyone's here, and I hope you all can take as much from this conference as I have, really. So Ken, do you want to proceed straight into the first agenda item?
Yes, go ahead.
Okay, so our first item on the agenda is an overview of the School of Engineering at UPES and its UPES India and its flagship projects. I'm sorry if I butchered that, but I'm going to turn this over to I think it's Dr. Kumar.
Dr. Kumar Chaturvedi, yeah.
Hi.
Hello.
Yeah. Can I share the screen? Hello. Hi, Luis.
Hey. Yeah, Ken, I don't know if you need to make him a presenter or.
Yeah, I'm a presenter. I will just share the screen.
Yes, Luis, yes.
Okay. So thank you, American Institute of Aeronautics and Astronautics, AIAA, LALV section, for inviting us to represent us on a very big platform to showcase ourselves, what we are doing at UPES, which is the university. Basically, it was University of Petroleum and Energy Studies, UPES Dehradun. It is located in the northern part of India. And so we at, my name is Sudhir Kumar Chaturvedi, and I am associate professor in School of Engineering at UPES Dehradun. So we have started one very important task, which is the flagship project since last year. And we have actually the 4 different projects. The number 1 is flying cars. Second is disaster management. Third is rural development. And number 4th is the urban development. So in that case, we have, since this conference, this mini conference is related to aeronautics. So we have chosen one particular topic, which is the flying car. And in our school life, we have a different branches of engineering, aerospace engineering, mechanical, automotive. Then we have electronics, electrical, robotics, many branches of the engineering. So a lot of students are involved in this particular project. So I'll just give the overview of flying cars for around 10 to 15 minutes, what we are doing, how we are going to execute, what is the update till date. So basically, we know that what is the meaning of flying as well as the car. So there are two terms. Flying is having a various synonyms like, for example, aerial. Then we have a floating, soaring, drifting, or express. Then flapping. Then we have the mobility problem, gliding. Then you can say waving, winging, zooming, aeronautical. Then airborne, avion, mercurial, on the wing. Then speedy as well as the volant. So basically anything which can be able to fly in the air. For example, as an aerospace engineer or aeronautical engineer, everyone knows everything flies because of the pressure difference between the lower surface as well as the upper surface. So what will happen if we have the car and that car can be able to fly into the tropospheric region, obviously. So in order to fly that particular thing, so complete design, development, and R&D, everything should be different. Depends on the CG, depends on the aerodynamic design of a particular car, or you can say the wing. So everything should be different. We have the aeroplane, we have the UAVs, we have autonomous UAVs. So for that, we have a different CG criteria, different aerodynamic center criteria. So what will happen in case of the cars? So if we know the center of gravity or the other parameters related to the car, and that can be integrated with respect to the some kind of the rotors, so that rotor can be able to lift. So obviously we have to balance the lift by drag ratio. That is a somewhat more technical term. So basically flying car, this is the project what we have started to design, to develop, to innovate the car which can be able to fly into the tropospheric region for the easiness, for doing the easiness of the business, or you can say for which can be beneficial for the society. So how the concept has come, basically, everyone knows that like we have a different kind of rovers or different kind of the aircraft, and then some of the concept from the biomimetics. Nowadays a lot of researchers are doing research in the biomimetics. So from there we can be able to take the some kind of a concept that can also be useful in order to design our wings or the rotors, so that they can be able to take off from one position to the another position in terms of the vertical takeoff and landing, or you can say into the normal form. Already we have the helicopters, but helicopters are very heavy, very bulky, and that can be useful for defense application mostly. But in case of the flying cars, we can be able to go with the commercial application. So we have to design the things in such a way that it should be completely on the balanced mode. You can see this is just an example. It should be correctly aerodynamically, aerodynamic shape should be very high, or L by D ratio should be very good, or the complete location of the tires from the nose wheel to the backside wheel, everything should be completely measured, monitored, as well as it should be balanced, so that it will provide the accurate as well as the precise lift value, drag value, as well as the thrust and other vectoring values. So everyone knows about this, the part of the aircraft. We have a nose, we have a undercarriage wheel, then wings, jet engine, and we have a tail plane, or you can say the horizontal stabilizer, vertical stabilizer. Then we have a cabin crew, fuselage, and everything this is related to the aircraft. So what will happen if aircraft plus cars, or you can say if the rotor and then car used to be designed. So if these two will be integrated, then it will give the value of a flying machine, or you can say the flying car. So these flying cars nowadays, it is under development, it is under innovation, and especially in India, we don't have much information, or we don't have the innovation related to the flying cars. So that will be the completely new idea which we are going to monitor, which we are going to design and give the proposal to the government, so that we could be able to get the funding and in order to proceed for the complete manufacturing at in-house at our university level. So how the concept has come again, what is the propulsion technology? We have the power system, we have the a different kind of For example, if this is a drone, this is also a kind of a flying car, or you can say it is the autonomous vehicle which is flying into the tropospheric region. And everything is controlled by these four different vectors, whether it is a drag or the gravity or the lift or thrust. And then furthermore, we have the concept of airships. So airships, again, that is also very important in order to doing the business in a very easy manner. So that's also the researches are going on how a weather balloon can be able to, or the airships can be able to useful for, taking out the payloads from one position to the another position. So we have finalized at School of Engineering flagship project different themes as well as the corresponding sub themes. So how the impact, what will be the impact or the ecological impact will happen once we will design it. So for example, if ecological themes we want to see, so under that we have a different sub themes of aeroacoustics, then what will be the sustainability, then ethics value. Similarly, what kind of the sensors we are using, either in terms of automation, communication, then what kind of types, as well as the new kind of the sensor, or what will be the application. Similarly, what materials we are going to choose. So obviously we have to go with the type as well as the any novel material that can be useful for flying it. Then we have the manufacturing, then what kind of the tools we have to use, then what kind of the MEMS technology we can be able to use. Then again in the themes, we have the energy. So whether we will use fuels or any kind of the renewable energy, battery power, as well as the power management system. Then we have the propulsion. So in propulsion, we either we can use engine, or you can say the powertrain, ground travel, or how the takeoff as well as the landing takes place. Then in case of the ground travel, we have the whether we want to fly from the flat road, or steep road, off road, or the extreme down, or sometime onto the hilly region, how we can be able to fly. So everything is completely micromanaged, and we have thought a lot of things in the flying car, how the things will work, how the project can be executed at the theme level as well as the sub theme level. So whether the flying can go under the water and then it will come back, that also concept we have to design, how the underwater vehicles can be able to float it down. And if we want to mapping the underwater things, so whether it can be able to go into the water up to what depth, and what kind of the bathymetry phenomena it can be able to go ahead. So in case of the air travel, so we have a takeoff mode, then flying modes, then we have a landing modes or the drones. Then underwater travel, whether what kind of the water depth protection, then whether it is a free flowing onto the surface we have to fly, or like for example we have the seaplanes also that can land onto the surface of the sea, and then it can be able to move into the space or into the tropospheric region. Then 2D control or 1D depth control. So a lot of discussions have already been discussed, as well as it is going on as an ongoing project which we are going to propose, and we are doing along with the students. So what kind of the jet packs, so whether it is a turbojet engine, thrust, or the balancing, or you can say the control. Then we have the modeling and simulation, so electrical, mechanical, static, as well as the dynamic modeling, as well as the operational scenario. So under these themes, these are the important themes, how the sub themes used to vary. So these are completely directly proportional. If we are selecting one theme, we have to execute all the sub themes. In a similar way, we have again classified in the further mode. If we have the flying car, so obviously we need the maintenance, so service, repair, operation, and other stuff. Then we have the infrastructure, so whether we have a charging network, laboratory, hangars, where to stand the particular thing, and then accordingly training simulators. Then obviously data analytics, so whatever the data we are analyzing in terms of the databases, data gathering, data structuring, as well as the storage. So everything is like nowadays we have the IoT things. So data should be storage in the form of a very highly precise valuable chips, into which the data has to be stored, and that has to be transmitted to the ground. So what kind of the market values we have, whether we want to procure it, or we want to go ahead with the private sectors, or with the commercial, local, or the regional, what kind of the stakeholders are involved. Our university, then we have a different regulatory bodies, markets, as well as the NGOs. Then we have the disseminations like articles, technology transfer, prototype, as well as the simulator. Then these are the very, very important themes, like how to connect with the other, projects. Like I told, we have four different projects of smart cities, disaster management, as well as the rural technology. So how the flying car can be able to, managed, or can be able to link to other flagship projects, what we are doing for the smart transportation or traffic avoidance, collision avoidance system in terms of the air taxi or the autonomous system. Similarly, for the disaster management, whether it can be used for the mapping, area mapping, search and relief operation, evacuation, or air ambulance, as well as the linkage to the rural technology in terms of the precise agriculture, transport, supply chain, as well as the biofuels. So everything, all the flagship project of School of Engineering are correlated, connected, as well as precisely monitored in terms of flying car or smart cities or disaster management, or in terms of the rural technology. So these are the very, very important parameters on which we are working, and along with our students. So this is the basic module for 1 to 2 year. For example, if we talk about 21, 22. So in year 21 and 22, this is the 5-year projects. This is the 23, 24, and 25. So what kind of the work we are doing? So in demonstration, land vehicle, normal terrain, then we have a drone, on water, underwater, jetpacks, parachute, as well as the gliders. So these we have to design, we have to innovate, and then we have to demonstrate to the society. That society may be anything, whether we want to go into the city and demonstrate, or go to the village and demonstrate to the person, so that they can be able to know the uses of the flying car. Then in the year 2, or you can say in the module 2, we have the demonstrator of increasing the payload value, then how to spin launch through or space vehicle, if we want to go for the advanced thing, and then regulators as well as the industry meet to get the different funding values. Then we have the floating car in the year number 3. So floating car, then floating car takeoff, then on water landing, then we have a hydroplaning, then boat mode, or the single or multiple hull. And then finally, into the final year, we could be able to completely design and monitor for the completely air, then underwater, and again to the space. So this is the complete very big project which we have taken up, and we are sure that we could be able to do. So we have a different team of 30 faculty members, along with the 100 students, with all the School of Engineering clusters like mechanical, electrical, applied sciences, or sustainability clusters. And there is a cross flagship members also. They can also be the part of this mega event. What kind of the events can be able to plan, or outcome of this particular things will be the mega event, or the workshop, demonstrations, then conference, international conference, then school connect program, and then finally the complete demonstration. So complete involvement of the faculty, staff, student, industries, regulatory bodies, government, clusters, as well as the flagship. So this is the complete integration of School of Engineering flagship project, the flying cars, in which we could be able to monitor, we could be able to map, and we could be able to design the complete thing, which is the theme: land vehicle, drone, on water, underwater, jetpacks, or gliders, or the parachutes. So we want to design, we want to develop the flying car in such a way that it should fly into air, it should float onto the sea, it should go underwater, and then from underwater it should go into the tropospheric region, or into the space. That is the complete all about so obviously in order to design the one particular flying car, it takes a lot of effort, lot of energy, lot of communication problem, lot of mechanical things which has to be involved, which has to be moved out, that can be able to control in terms of the autonomous way, in terms of the manual way. And obviously we will try our best to do the R&D and do the innovation and do the manufacturing at University of Petroleum, UPES, Dehradun, and we will try to showcase it maybe in the next 3 or 4 years. At least 1 or 2 flying cars we could be able to manufacture it with the help of different stakeholders, especially from the government regulators, as well as the government bodies, as well as the private industry. So it is a kind of the academic industry interface, or academic government interface, through which we could be able to manufacture it, and we could be able to demonstrate to the different stakeholders into the market at national level as well as the international level. Our students will showcase the the project of a flying car at international level, so that the international people, like for example in AIAA forum or in IEEE forum, one can be able to understand what we are doing and how we could be able to go ahead with the different kind of mega events or the workshop. So at UPS also we will try to organize every year or every 6 months the kind of a mega event what we are doing in a different flagship program. So this is all about the flying car flagship project. What was our first talk. So the next talk will be the UAVs, unmanned aerial vehicles, which is the global flying machines. So we know that UAVs are basically very, very important nowadays, and it is completely, sometime it is a manual, sometime autonomous, sometime it is the basically a flying machine which is flying into the air, especially into the troposphere, maximum 1 kilometer or 2 kilometer above the Earth's surface for a small kind of UAV. But if we have a very big, larger UAVs, and they can be able to fly, like an aircraft. So basically, everything which is to be controlled by means of the autonomous way or by means of the manual way, so they are known as the UAV. So they have a lot of difference or a lot of applications into the UAV. So what it is exactly? So basically, they are the remotely operated aircraft, or you can say autonomous aircraft, which are controlled by means of different sensors. They are the highly flexible platform. They have a sensor dependent, basically. Sensors means anything which can be able to sense remotely. So they are the sensor dependent and optional. They are the optional autonomy also, and highly flexible platform. So whatever the things, whatever the sensors we are mounting on a particular UAV, that has to be monitored. And in what application we are using. For example, if we want to go for 1 kilometer above the Earth's surface, or 2 kilometer, or 10 kilometers. So for 10 kilometers or 15 kilometers, we already have the aircraft. For the lower region mapping, we have to use the unmanned aerial vehicles, or in general terms, we are calling it as a drones. For the higher altitude, we have the satellites for the larger coverage. So these satellites can monitor the complete globe on a larger scale. Aircraft can monitor at a moderate scale, and the UAVs can moderate into the, or they can be able to monitor at the smaller scale. So these are the important parameters in case of the unmanned aerial vehicles, or sometimes we used to call it as the unmanned aerial system. It is the system which is flying into the air without the consent of manual operator. That is the actual task. But basically we are using it like, for example, 2.4 gigahertz transmitter frequency system for controlling the aircraft or for controlling the drones, so that it cannot move beyond the line of sight, because line of sight is very important for UAVs flying. So how the birth of UAV actually occurred? So basically, in 1916, it has been started after the World War I, which was developed by a film star and model airplane, this enthusiastic, whose name was Reginald Denny in 1935. So the birth of United States UAV began in 1959, and US Air Force officers were concerned about losing the pilot over the hostile territory. So August 2nd and 4th in 1964, US Navy initiated the America's highly classified UAVs in their first combat mission during the Vietnam War. So these are just a history, what I have taken from the different references. So subsystem of UAV consists of, it operates at ultra high frequency. Then we have, it communicates with the Ku band, or it can operate in the L band or C band also. And different navigation purposes are used for the satellite-based systems such as GPS or WAS, and it calculates the positions automatically. It means basically UAVs can be able to, in UAVs we have the system or the sensors which senses or which stores the data in terms of the latitude or longitude as well as the altitude. So if you want to fly from one position, so for every position X1, Y1, Z1 as well as the T1, it should move to the another position, then it will move to the another position, then third, fourth, 5, 6. So everything there should be a different coordinate value. So coordinate 1, coordinate 2, 3, 4, 5, 6. In that way, we have to use it. So it is basically the navigation. So this navigation occurs by means of the guidance parameter. or the coordinate parameters. So all the coordinate parameters should be fed to the UAV for the monitoring. So yes, that's what I was explaining for the satellites. It provides the larger coverage to the particular things in order to complete the mission requirement. But for the UAVs, it can be able to monitor with a very precise information over a very shorter distance. So it can be able to cover, it can be able to monitor a smaller area. So for imaging, or you can say for the video processing, one can be able to see, like in most of the marriage functions, or in most of the this movies recording, we are using this UAVs for which can be the data recording system, and that data recording system can really used to transmit the information towards the ground station, and that can further be monitored as well as the transmitted to the different things for different applications. So like if we talk about in Indian UAV, so we have DRDO, which is the Defense R&D Organization, as well as the Hindustan Aeronautics Limited, and they used to develop the UAV by means of different things, or you can say we have a Lakshya or DRDO Rustam. This is the name of the UAVs. Some of the UAVs which is being developed by these DRDO as well as the HAL, Nishant. Then we have a Pawan or Fluffy. So these are the name of the UAVs in which different controllers are used, different parameters are used to design as well as the develop, and that can further be monitored for different applications. That has been deployed to the Indian Air Force or to the military for the different applications for applications. So what are the various significance of UAVs? It removes the risk of life, reduces the human error, then it has a lower cost to mainstay the aircraft, then it is a longer loiter time. It means the operational capabilities are very high, and easier networking as well as the highly reliable. Sometime it cannot, because if there is a loss of signal, if there is a loss of line of sight, so obviously it will crash. But yes, most of the time it used to provide the real-time information. So these are the some of the important significance for the global flying machines. So how it has been classified, or it can be able to classify it. So we have in terms of what requirement we want, whether we want to go for the logisticals or R&D applications, commercial applications, or the combat applications. So what are the functional requirement, and depends on the altitude, how can we able to fly. For example, low altitude, high low range endurance, low endurance, so it is LALE. Then we have medium altitude, MALE, male. Then we have the high altitude and long endurance. Basically, endurance means endurance means it is the time.
Is that where the cursor is?
Yeah, you try it.
Well, I'm afraid to try it. I might screw it up. I don't know.
Hello. Shall I proceed?
Yes, please. Sorry about that.
Yeah. So these are the basic classifications. So endurance means time. So what is the power backup? How the power backup? What kind of the batteries we are using? So whether we are using, nowadays we are, we are doing the research on, or researchers are doing the research on renewable energy sources. Like for example, solar plate, they can be able to deploy over the wing, and so that they can be able to get the energy from the sun, and that has to be monitored, that has to be moved out, that has to be used for the power backup for flying this particular UAV. So we have the low altitude long endurance, medium altitude long endurance, as well as the high altitude long endurance. So obviously all the mission requirement are different. So power requirement will be different, mission requirement different, power requirement different. Then we have the endurance value will be different, height value will be different. All the coordinate system will be different in all these three conditions. So basically, classification of UAV can also be done by means of the unpowered and powered. So in case of the unpowered, we have lighter than air system. That is very, very important, parameters. Nowadays, a lot of things like, for example, I know one professor, R.K. Pant. So he's a very famous, scientist or professor in India, who is working in the LTA laboratory in IIT Bombay. So he used to work upon airships as well as the weather balloon problems. So that's very important. And once I remember he had given one seminar at our university that was very interesting on lighter than air system. So that was again a very important as well as the interesting area nowadays to study upon how the balloon or the airships can be useful for the society to move from one place to the another place. Then we have the heavier than air. So in that case, we have the flexible wing, fixed wing, rotary wings, gliders, and rotor kites. Everyone knows. Then they are the unpowered, in which the power is not so much required to fly. Right? If we want to go for the power, so obviously we should have the propeller or the jet engine in terms of the single rotor, coaxial, quadcopter, or the multicopter. And again, UAV classifications can be in terms of motorized kite, or you can say the quadcopter, in which you can see there are 4 different propellers are interconnected with each other with the controller. Octocopter, single copter, helicopter, or any kind of the fixed wing UAV. So basically, it is classified by means of fixed wing as well as the rotating wing. So fixed wing is just like an aircraft. A rotating wing is like quadcopter, hexacopter, or for the small toys kind of thing. They can be able to go ahead and monitor. Like recently, this Amazon, they are delivering the packages during the COVID time from one place to another place. A lot of people, a lot of commercial organizations, they have come across and they have procured the UAVs for their own applications. So even today, I was reading one news in India. One of the UAV, they took the sample of the blood, they collected the blood, and they moved out from one place to another place, and the endurance was 1 hour. It means they went from one city called Meerut in Uttar Pradesh. From Meerut to Delhi, it covered in 1 hour, and they took the blood samples for the testing at that particular thing. So that kind of advancement is required nowadays to get the values done, to get the test done, to get the procurement done in a very shorter period of the time. So in India, we have, like I already discussed about the Shan, then Rustam, then we have AD, Lakshya. These are the some name of the UAVs under which the researches are going on within our country. So the basic working is like we have unmanned system or the aircraft, and we have traffic controlling as well as the pilot sometime. So this pilot can be able to monitor it if it is an unmanned aircraft, but yes, pilot is important to monitor it by means of the giving the command of the transmitting as well as the receiving signal. And ATC is used to control this particular aircraft so that it should not go beyond that. If the radius, for example, if the UAV radius is, let's say, if it is, let's say 1 kilometer, right? So this UAV, you are the origin or the standing position. So this UAV should fly within the range of 1 kilometer or the diameter of 2 kilometers. If it is going beyond that, it means it is non-line of sight, beyond the line of sight. If it is between the 1 kilometer, it is the line of sight command. So within this, UAV should be monitored. So obviously guidance and navigation, as well as the controller design for the UAV systems or the unmanned aerial system should be very strong, should be very accurate, so that it should move within this particular coordinate value. It should not go beyond the it should not go towards the non-line of sight condition. So these are some of the basic applications for targeting, then target practice, then we have surveillance, then we have a seed, and in civil application, delivery of the packages, surveying and mapping, film or photography, entertainment, as well as the agriculture things. So these are some of the important, like in COVID time, and most of the companies, they have taken up the project for sanitization. So they have filled up the sanitizer tank, depends on the payload, 10 kg or 20 kg or 15 kg. And then accordingly into the area wise, they used to sanitize it. And then furthermore, they have to clean it up during the COVID-19 pandemic. So it was again a very important, as well as the for delivering, for surveying, for mapping. And most of the time we are using for mapping as well as the surveying, especially for the agriculture crop monitoring. So we have to monitor the crop at every 1 month or at every 15 days. So we have to get the data. Data means obviously in terms of the images. So it depends on what kind of the images we want, whether we want RGB image or thermal image or visual infrared images. So they are the very important to have the very good sensor. So sometimes forest fire monitoring, for example, in disaster management project, we are doing the forest fire or the sometimes landslide mapping. So for a particular area, if there are going to be the landslides, so what kind of the geological properties are studied. So based on the image scattering, based on the reflection of the data, reflection of the images, one can be able to monitor it as well as predict the next value. So these are some of the hydrological aspects, how the UAVs can be able to fly. For example, if it flies from one position, it will move to the another second position, then again it will go back, and then again it will come back, right? So this is how the values can be able to monitor. So at each and every depth or at each and every point, one can be able to classify the water as well as the land area. So this all hydrological application, this is the land area basically. So into this, one can be able to monitor up to what area this complete water is contaminated, or how the contamination.
Dr. Kumar, I'm so sorry to interrupt. I think you're muted.
Sorry. Okay, just fine. Yeah, now it is okay.
Yes.
Am I audible? I don't know. Yeah. Yeah, I will just finish in 5 to 10 minutes then because we are already lagging of time. So what kind of the sensors we have is the multispectral cameras, then SAR, which is the very important sensor, but the cost is very high. The payload is very high. So we are not using mostly the radar as well as the SAR into the small drone UAVs, but yes, for the aircraft, we are using it. Then we have a LiDAR sensor, GPS, obviously we have to use it to find out the position. So these are some of the very important electro-optical sensor as well as the cameras for the applications of disaster management especially. What are the various limitations? So obviously there is a cyber crime, so that can be hacked. So it depends on the software. The software can also be hacked. So we have to use the very important IP protocol to procure it, to monitor it regularly, so that it should not be able to get air traffic congestion or the information losses. Sometimes it happens. It should not happen actually, or most of the time unemployment. But nowadays we have a different drone policies. But yes, very soon we could be able to come up with the various applications of the drones, some more advanced application. And then again, the limitations of reduces the ethical decision making. So what are the scope in terms of the for the drone? We have a swarm technology, like we have the masters and different slaves, and they can be able to continuously form the data. If let's say if there is a one UAV A and it has a number of UAVs into the space, for example 1 2 3 4 5 6 7. So this A is the master UAV, which is continuously getting the data from all different kind of the UAVs. So it acts like a multiple input system, a multiple input single output system kind of thing, because this system is only giving the output to the user, right, of this all 7 UAVs. So this is known as the swarm intelligence, or you can say that can be useful for the swarm technology. Then we have the autonomous air travel or the space exploration. So a lot of applications or the scope as well as the futures are there for the unmanned aerial systems, and that can be able to like I told in the flagship project, we are going into the water also. So that is known as the aero unamphibious vehicle. Basically, that is the technical aeronautical term in which they can fly into the air, onto the sea surface, and then onto the water. Yeah, so some of the references, whatever I have taken the pictures or some other things that has been covered. So these are the few references from different UAVs, what I have already discussed. So thank you so much for attending the talk and understanding the what we are doing at University of Petroleum at UPES Dehradun. And yes, obviously we are looking forward to collaborate with AIAA. And so I'm over to the organizer of this event, Mr. Lewis and Mr. Dr. Kane. So I'm open to the question as well as my students will give the next talk. Thank you so much. Thank you.
Thank you so much, Dr. Kumar. And as he said, if you have any questions for him, please go ahead and throw it in the chat. I have a question for you right off the bat. So on your UAS presentation, which is what we just saw, what's the most exciting application you see for UAS?
The most exciting is, according to me, it is the agriculture monitoring as well as the forest fire mapping, because here where our university is in state of Uttarakhand. So especially in the summer season, it's completely dry. So dry means anywhere if you put up the light, then it will completely under the fire. So most of the forests are completely under the fire most of the time. So yes, by means of the drone, by means of the UAV, we can be able to map it, and then we can give to the disaster management authority. Okay, this should not happen, and this should the amount of fire is proceeding from one place to the another place. So that should be recovered. That should be monitored. And also into the agriculture mapping, it is very important to have this thing, because continuous monitoring of crops are very important. Right, so because sometimes the flooding used to come, sometimes drought used to come, so that kind of the predictability or the amount of the prediction can be made using by studying the image data, by image data sets or the comparative. So that is the most important application according to me for the UAS.
Okay, great. I have a question here in the chat. The question asked, it's from Dr. Kumar. Are you using Indian Regional Navigation Satellite System for drone application? If you are, how reliable is it in your monitoring application?
Yes, I think we are using, so we can use by means of the integration way. Like if we have the satellite data and we have the local, UAV surveillance data, that has to be integrated, and then the integrated data or the integrated image can be able to measure or monitor the application, in what application you want to use. So basically, integration technique should be very important, signal integration or the image integration. So that can be monitored, or that can be tested out.
Gotcha. And are you developing the software used to monitor the data?
Sorry.
So are you developing? I guess what's the software you use to take in the data?
Presently, for US study, we are using the open source software like Open Drone, right? So for that only we used to get the data, live data, and then we used to process it for the application.
And sorry, that question was for my own curiosity and edification.
Yeah.
Thank you.
But yes, of course, in future we can be able to develop our own software to monitor it. Depends on our UAV requirement.
Gotcha. Yeah, I mean, it sounds like it's a geographical issue that you're trying to solve. So I commend you for that. It sounds very exciting. So I think if there's no more questions, we can proceed along the agenda. Dr. Kumar, thank you so much for that overview. It's very ambitious, I can see. It's going to be a multi-year project. And again, thank you for your presentations.
Thank you.
Moving on. So the next presentation is regarding propulsion control architecture for small electronic aircraft. And this will be a presentation by Shivangi Singh, and I apologize if I'm pronouncing your name incorrectly, but I understand they are in their final year of study at the UPES India in focusing on aerospace engineering. So I'd like to turn the discussion over to Shivangi.
Yeah, hi, thank you for the opportunity. I'll just share my screen now.
Yes.
Okay, so first of all, I'm very grateful for this opportunity by AIAA LALV talk of this mini conference. So I myself, Shivangi Singh from B.Tech Aerospace final year. in University of Petroleum Energy Studies, Dehradun, India. I'm going to introduce my project, that is the design validation of propulsion control architecture for small electric aircraft. Basically, the focusing on the air taxis, which is guided by my faculty mentor, Dr. Sudhir Kumar Chaturvedi sir. So talking about how what made us realize about the project is due to as we all know, that the world is facing an environmental crisis due to depleting fossil fuels and pollution caused by its byproducts. So alternative energy sources are explored to mitigate the crisis. So this project proposes the study of currently operational and in development electric aircraft, understanding their propulsion and power system architecture. So the development of architecture could readily revolutionize the Indian and global aviation sector with the lowest price and provide maximum returns on efforts, as it would directly return on it in the aviation companies worldwide. Now, getting on to the introduction here, as you can see, the word itself, the electric aircraft, is the electrification as the propulsion system has opened the door to the new paradigm of propulsion system configurations and novel aircraft design. The aviation sectors had evolved significantly with the improvements in propulsion system technologies, to deal with air traffic demand control growth and surges in fuel prices in an environmentally economic, sustainable manner, with the growing demand of fuel
Sorry,
and
Shivangi.
gases.
Sorry, Shivangi. Can you switch
Yeah.
on your video, please? Video also, please.
Just, yeah, sure, sir. Yeah. Now, the challenges which we are facing right now with the electric aircraft is the electrification of aviation, the storage problems of the batteries, and the weight distribution. The battery's low energy density, lithium being the primary element in the chemical composition of the battery, and the mining of lithium is a stout process. So the initial costing system of the propulsion system is also a challenge to us, which also comes with a safety and robustness. The major area is here the battery and the weight problem, and some of the drawbacks with the uh, battery to be switched apart from lithium. Now talking on to the objective. The main objective of the project is to analyze the current system of the efficiency of the aircraft. The recent development so far in the electric aircraft has been the hybrid and also the all electric, but it's not so much in the market right now. Understanding the propulsion and the power system, design control system architecture, and the simulation of aircraft design. These are the recent aircraft, all-electric aircraft. Number one, as you can see, is the Rolls-Royce all-electric Spirit of Innovation, propelled by 400 kilowatt-hour electric propulsion, giving the world record of journey towards the decarbonization. The next is the NASA's Maxwell X-57, is an experiment by the NASA using the LEAP technology, and one of them is also Boeing Phantom, is a fuel cell and a battery power motor glider which is capable of flying 40 kT. And and the last one you can see is the Joby Aviation. Now the research gap till we have found is the Joby Aviation, which matches our type of air taxi. It has a 4 passengers pilot seat with a maximum speed of 200 mph and the range of 150 above miles. Has also has completed its 1000 plus test and been considered as a environmentally safe with less of the carbon content. While selecting our battery, we have came in the following consideration, that is the energy density, power density, durability, lifetime, environment consideration. Why energy density? Could be the energy to weight ratio, that density affects the flight range, the power density. When a device has high power density, it means that the high sustain draws for a large period of time. The durability, because of physical factors that greatly affect the performance of your battery. Different battery characteristics are susceptible to the other factors such as temperature, humidity, also the lifetime. There are main two batteries lifetime, that is the charge life and the total life, and also taking in consideration of the environmental, because since we have discussed the lithium ions and the polymers are somewhat hazardous to the environment, so substitutes are still on the findings. These are the references that I have used so far in my project. Yeah, thank you for the opportunity. Thank you, everyone.
Thank you, Shivangi. Again, if anyone has any questions, please drop them in the chat. I have a quick question for you as far as how long do you think it'll take before electric aircraft are, I guess, feasible or can travel longer distances? You know, it's really a question about feasibility. What's your opinion on that?
I guess it won't take much of a time, maybe 5 to 3 years to build a air taxi for a limited city exposures. And also if the battery system thing is solved, then I guess 5 years for the better transportation would be enough.
Okay, great. If anyone has any questions, please drop them in the chat. But again, thank you for your presentation, Shivangi.
Thank you so much.
Thank you. Okay, moving on to our next agenda item. We have another presentation from UPES India. This presentation is regarding controller study and the design of autonomous underwater vehicles. It's a topic I know nothing about, so I'm very excited. This is going to be presented by Mahima Gupta, again, another student at the university and in her final year of the Aerospace engineering degree. So I'd like to turn over the mic over to Mahima Gupta. The floor is yours.
Yeah, hi. Hello, everyone. Let me share my screen for the presentation. Okay. Yeah, hello, my name is Mahima Gupta, and I am a final year student who is pursuing B.Tech in Aerospace Engineering with specialization in Avionics from UPES, Dehradun, India. Today, I am honored to present and share my opinion on our ongoing project with you all. Before starting my presentation, I would like to thank my professor and mentor, Dr. Sudhir Kumar Chaturvedi, and also I would like to thank AIAA for providing us the opportunity to express and share our thoughts and motivating us by organizing such events. So yeah, allow me to start the presentation now. Okay. So today my topic for the presentation is controller study and design of an autonomous underwater vehicle, AUV. This is the team project which I'm doing with my team that includes 2 more students from my batch. And I am here on behalf of my team to present this presentation under the guidance of our professor. So let's start with what is this topic all about? That is the introduction. So yeah, unmanned underwater vehicles have gained popularity over the last decades or so, especially for the purpose of not risking human life or dangerous operations, since it includes very high depths and trust in the pressure, which our bodies are not prepared for. Many examples of remotely operated vehicles such as ROVs and autonomous underwater vehicles, AUVs, were developed and used successfully on various applications such as oceanographic surveys, bathymetric measurements, underwater maintenance activities. Example, those were performed at oil maintenance activities, fiber optic communication lines, etc. And of course, the military defense. The design of guidance and control system of these vehicles required knowledge of a broad field of disciplines, including velocity, including the velocities, vectorial kinematics and dynamatics, hydrodynamics, navigation system, and control theory. So, in order to specify the vehicle dynamics behavior in a fluid environment, it is essential to have a coordinate system. So, an autonomous underwater vehicle (AUV) can be considered as a rigid body with 6 degrees of freedom. Therefore, in order to represent its motion, six independent coordinates will be needed, as is shown in the figure 2, which represents the coordinate system of body fixed and inertial. So now moving on to the objective of our presentation, what it has. So number 1, to analyze the various control systems for AUV in the presence of environmental disturbances, improved robustness and performance of an underwater vehicle that can be achieved using low closed loop control system of PID type, that is proportional, derivative and integral, instead of an open loop control scheme. In closed loop control approach, sensor and navigation data are used for feedback. So the basic task in autonomous underwater system are depth and steering controls. Numerous control strategies have been adopted. Certainly, there are many, and all of them have advantages and disadvantages, as we know, pros and cons. So it is possible to classify the algorithm into two main groups, that is linear and non-linear, according to our research and analysis. Second, the understanding of an AUV system. Since we are engineering students, it was a really new topic for us to dwell on and to do a project. So, and then comes the design of controller of autonomous underwater vehicles, including the simulation and a two-level system control that is proposed in our project. The primary level was to control the navigation of the vehicle, whereas where a linear controller is proposed, whereas in secondary level, guidance system, collision system, start and stop and abort mission events will be ordered, while the neurofuzzy controller. Uh, so the neurofuzzy controller I'll explain on further upcoming slides. Before that, the implementation of these algorithms will be supported by a Motorola Coldfire family microcontroller, that is MCF 5272 to be very specific. Speaking of algorithm, next come the methodology and the mathematical model representation. Yeah, so a proposed method in a research we have done for developing FL controller based on mathematically obtained dependency. These dependency were related to the vector of states of input quantities to control solution to the output of for symmetric triangles reduced to the degree of exponential, Gaussian, and other forms of memberships function with two or more terms in the coordinate systems. I know this is new terms, but okay, I'll explain in a layman language. So when designing and implementing such FL controller, there is no need of use of fuzzy logic software environment, and the procedure for designing them is to reduce the programming, that is the corresponding mathematical dependency. And how we'll do that? So for such regulators are configured by modeling the behavior of the controller systems. For example, in the simulation environment of the MATLAB, the interactive systems is used by reducing the input and output vector ranges to a single scale. So a generalized functional diagram, which you can see on the left side, figure 1. So a generalized functional diagram of such FL controller is shown. That is the figure 1, which states the input ADC, normalization of the input signals, then neuro control network computer, then normalizing of output signals, and then the control object. And then to the right side, it is the symmetric diagram of the control system with the neuro networks of FL controller, which is proposed for calculating the different model, that is degree of freedoms, and the knowledge base which is to be set in a particular model, calculating the values of A and B, which is again the coordinate system, like it has stated the normalization of inputs. Yeah, this one. So normalization of the inputs, then the degrees, then it's the time response at what it is responding, then calculating the values of A and B, then the output and setting option, normalizing to the output signals, which we have considered guidance systems and navigation. So moving on to the proposed model. Yeah. Proposed model, in this we have taken into account many behaviors. So we have done the behavior based formulation, behavior of moving towards the goal, behavior of avoiding obstacles, wall following behavior, behavior of avoiding collision with other AUVs or any collision which it will detect, behavior of keeping the formation. So the overall behavior that has been conducted by a robot is the combination of several goals, like as discussed, avoiding obstacle, wall following, avoiding robot, and the formation keeping. In practical application, each behavior of a robot is stated as the form of a vector that consists of the magnitude and the direction. The weight of the vector, that is the density of the behavior, can be changed by adjusting the parameters based on the information detected from the surroundings of the environment, and the robot chooses the proper behavior. Therefore, a movement command will be produced, and the overall behavior vector, which is the sum of all sub behaviors vectors, is considered. So the figure depicts on the right side above is the model of a single robot and its sonar sensors, A and B showing the lasers of sonar sensors, and towards the down it depicts the process of avoiding large obstacles, which is again this one, which is again through a response thing. Next, moving on to the challenges that we faced here. So there are several challenges that we face. First of all, the adoption of neuro fuzzy controller. We had to research a lot regarding this, and literature reviews and all. The main problem of an AUV controller are the parametric uncertainties. For example, added mass, which was one, hydrodynamic coefficients, etc., and non-linear and coupled dynamics too. So we considered all of this. In order to achieve a high degree of autonomy, several engineering problems were associated with the high density, non-uniformity, and associated with the unstructured seawater environment, that is the disturbances, etc. And also the non-linear response of the vehicle were there that we considered, and definitely we are overcoming, and few of them we have overcome. Next, then comes the behavior based formulation together with the use of FL controllers, which was very new to us. Of course, with the guidance of our mentor, we had overcome this too. The most important thing was the propulsion system and the input sensor, which include the baseline design structure of autonomous underwater vehicle. To achieve this desperate goal of high thrust, small size, and precise propeller position, instrumentation was done, and we have developed a compact 3-phase DC electric thruster. So the thruster is internally pressure compensated with mineral oil and rated for full ocean depth operations. At last, the design of a more complex embedded system, along with the reliability and, of course, most important, the certification, so that we can do further operations. Yeah. So these were the challenges that were faced in our project. Now, moving on to the architecture. So yeah, the architecture was designed for specifically a fail-safe system, redundancy, flexibility, and future-proof. So a control system structured in 2 levels for an autonomous underwater vehicle was proposed, as I stated previously. So, and under this, a control system proposal is presented for guidance and navigation. That is this structure. We'll see this executive part, base behavior controller, navigation, and supervisor, and the dynamic control and controllers. So yeah, the system bases on the common one used in marine vessels, and it is built by 3 dependent blocks identified as guidance system, control system, and navigation system. These systems interact between them by transmission of several signals and data representation as shown in the figure. So the guidance system is in charge of calculating the desired reference in every movement, position, velocity, and acceleration of the submarine that will be used in the control system. So the control system determines the necessary action of the forces and moments that is necessary to be provided to the submarine to satisfy the control target. Finally, the navigation system is in charge of determining the position, route, and distance that will be covered. This control structure was the control structure implementation is carried out in a MATLAB simulating for 2D as well as 3D purposes. Yeah, so these are the references that we have taken in account for our project and research studies. Thank you, everyone. Yeah, any questions? I'm open for.
Yeah, thank
questions.
you. Thank you so much, Mahima. This is it's been a great presentation. Again, like I mentioned, I knew nothing about underwater vehicles, so it's exciting that there's work being done in this area. You mentioned that type of vehicle, or the vehicle has 6 degrees of freedom, right?
Yeah.
Okay,
yeah.
and how did that complicate the creation of your fuzzy logic controller?
Yeah. So since since it has a 6 degree of freedom and it is a rigid body, so the challenges that we were facing during this was regarding the neurofuzzy controller. Since we are the simulation is done into is done in the MATLAB system. So it was very difficult to identify the rotation, the navigation system, and the movement for a very particular or short distance, or even for a longer distance in a particular span or particular time, since it was traveling 0.2 or 0.5 second for a very large distance. So it was hard to capture that movement of the AUV. So there we faced a challenge.
Okay.
And since it was a new topic for us too, so we had to do a lot of research, and we stuck in many topics as well.
Gotcha. Thank you. So Dr. Melamed asked a question for Shivangi, which I unfortunately missed. So I want to circle back to this question. I'd hate to miss it. This is a quick question for Shivangi's presentation regarding the architecture for small electric aircraft. This particular question is about the structure. Are there any special constraints on structure and weight for electric airplanes?
Yeah, as I mentioned, we are working on the air taxi, that is basically a 4-seater plus a piloted seat passenger aircraft. So we are in a specific constraint, and particularly we are on the research phase right now. So I can't give the numbers right now about the weight and the strength, but yeah, we basically the idea is for a small passenger seat, 4 to 5 passenger seat air taxi.
Okay, thank you. So if anyone has any questions for either Shivangi or Mahima after their great presentations, please drop them in the chat. Thank you to both of you for teaching us a little bit about electric aircraft and autonomous underwater vehicles. Again, Dr. Kumar, thank you for the overview about what's happening at UPES. It sounds very exciting, in my opinion. So if there's no,
Thanks.
sorry, quick question.
Thank you once again for giving us the opportunity, and we will try our best to open the AIAA student chapter at UPES. Thank you so much.
Yeah,
and I will again join during the panel discussion. So thank you so much.
thanks.
Thanks, Dr. K.
Seriously,
Thanks.
it's great. Okay, moving forward, I think it's time for our keynote speech by our keynote speaker, Dr. Henry Garrett. I'm going to talk a little bit about Dr. Garrett here. Dr. Garrett has over 150 publications on the space environment and its effects, with emphasis in areas regarding atmospheric physics, the low Earth ionosphere, radiation, micrometeoroids, space plasma environments, and effects on materials and systems in space. While on active duty in the Air Force, he served as project scientist for the highly successful SCADA program, which studied the effects of charging on spacecraft. For this effort, he was awarded the Harold Brown Award, the Air Force's highest scientific award. And in 1992, he was selected for a joint DoD NASA assignment at the Pentagon as part of the Ballistic Missile Defense Organization, where he acted as the Deputy Program Manager for the Clementine Lunar Mission and Program Manager for the Clementine Interstage Adapter Satellite. For these contributions on these missions, he was awarded NASA's Medal for Exceptional Engineering Achievement. And after a 30-year career in the Air Force Reserves, he retired in 2002 as a full colonel and was awarded the Air Force Legion of Merit. During his 40-year career at JPL, he was also responsible for defining the space environment and its effects on reliability for many NASA missions. He has also published several textbooks on the space environment and its impact on spacecraft design and reliability. Dr. Garrett is an international consultant on the terrestrial and interplanetary space environments and spacecraft reliability, having worked for Intelsat, Lagarde, NASDA, Loral, CNES, and other organizations. In 2006, Dr. Garrett received NASA's Exceptional Service Medal for his achievements in advancing the understanding of space environments and effects. Recently, he co-authored with Mr. Albert Whittlesey the primary NASA standard on spacecraft surface and internal charging for Earth missions. He retired from his duties at JPL in 2017, but continues in the emeritus position. Dr. Henry Garrett, please take it away.
Thank you for the wonderful introduction. Let me see, did I push the share screen, I guess? And then I do this. See if that worked. Come on. There we go. And let's do that. Oops, go back. Can you hear me? All right.
I can hear you all right, sir.
Okay. And does that look good on the screen?
Yes.
All right. So our talk today is going to be, I was asked to give a talk on the recent problems that the SpaceX had with its satellite constellation for the Starlink satellites. Fortunately, my first career move after I got out of graduate school was assigned as a young officer at the Air Force Cambridge Research Labs with the purpose of studying satellite drag and the effects of drag on satellite orbits and studying the atmosphere as a result. So at least I think I'm fairly well prepared to give the lecture today. Let me state the problem then for you. Satellite description. The SpaceX Starlinks had a problem recently. They're basically around 260 kilograms, as it says here, size of a small coffee table. The problem is that they're launching 30,000 of them into orbit. To be honest with you, one of my other big concerns at JPL is space debris. And in one fell swoop, they are creating the world's largest space debris problem. I actually asked at one of the AIAA meetings, I asked the lady who's director of SpaceX about it, and they don't seem to have any concerns. So I guess we'll not worry about it. And the problem that they had, however, is they've been launching these things in groups of 49. In fact, I think they just launched one about 2 days ago or yesterday of satellites at a time. And then they spread those out along the orbit. What they've been doing is they've been putting them into a low altitude orbit where they'll decay rapidly if they don't work. And that's down around 209 kilometers. And as we'll see, satellites in that orbit will decay very quickly. And then what they do is they check them out and move them up. What they forgot to take account of is that we're going into the solar maximum right now. And solar maximum, the sun affects the atmosphere quite efficiently. And you can get momentary surges in the density of the atmosphere. And as a result of that, several, to be precise, 40 of the satellites apparently have already re-entered before they could do anything about it. The cause of that was what we call a coronal mass ejection. I'll give a brief description of what a coronal mass ejection is and show you the one that, give you some definition of the one that occurred right before the failure of the satellites. The next thing is how did they explain how they tried to prevent the satellites from coming in. Basically, if you look down here in the lower right-hand corner, you can see what they look like. And unfortunately, it may actually turn out to look like that in space, which is kind of frightening. If you look at that picture. Between this one and this one, I think you see where we're going, unfortunately. Anyway, what they do is they turned the solar array here so that it was sideways, but they didn't turn them fast enough, so they lost 40 of them. They got 9 of them changed sideways so that the drag was less. But now, so that's basically the problem. What happened to the Starlink satellites? What can you do about it? And where are we going? Well, first of all, my agenda is following. I'd like to go briefly into what solar activity we need to be concerned about. How does that activity affect the Earth's magnetosphere and its atmosphere? And then how does the atmosphere respond when we have a geomagnetic storm? And what are the effects on the atmosphere on spacecraft? I'm going to concentrate today clearly on drag. Normally when I teach this, I have a 2-day course and I go into all the other effects also. How do you quantify drag on a spacecraft? I'll briefly describe the equation that probably most of you know about drag, and then show you what some of the parameters in there, how they have an effect on the satellite. And so what happened to the Starlink satellites? That's where we're going with this talk today. All right, here's some of the forms of solar activity that we have to concern ourselves with. The most basic one goes back to Galileo, for example, or what we call sunspot groups. You can see that up here on the left. And there's the Earth roughly compared to 1. Basically, if sunspots occur in groups of 2, one where the magnetic field goes in and one where the magnetic field goes out. And usually they're right next to each other. And then there's one, always typically a pair in the north, a pair in the south. And like I say, Galileo discovered that fact back in the 1600s. And then the sun turns with a 27-day period. So if you have an active region, such as a sunspot, you'll see it 27 days later. Now, this is what they look like on the side. It's called a prominence. And I'll show you some pictures I took. I have a little H-alpha telescope. I recommend everyone buy one so you can go out and look at the sun on your own. You can actually see these things on the side of the sun every day. You can watch them evolve. They can evolve very rapidly, and you can see them in real time as they come off. But this is basically one end was here, one end was here, and you can see the coronal arch that you see here that the prominence forms. Another thing is once these things can explode and the top opens out and this goes out into space, and you get this black region up here, which is what's called the coronal hole. There, the sun, rather than being trapped by the magnetic field of the sunspot or by the sun, the solar wind can go immediately expand outward from the sun and speeds up to, I've measured up to 3,000 kilometers per second. And that takes a little less than 3 days to reach the Earth. Typically, they're around 500 kilometers per second, but it's this black region in here that I'm talking about. So these basically cause reoccurring streams, as we'll see in a moment, where the Earth runs through one of these streams and the activity goes up. So you have the sporadic things like these, and then the biggest ones are called coronal mass ejections. That's where, this is the sun's disk down here, and I'll show you some movies of those in just a second and give you a feel for what a coronal mass ejection looks like. It's basically a huge plasma cloud that's forced outwards from the sun and goes and ultimately crashes into the Earth. And like I say, they can reach here in under 3 days. Now look down here at the left. Now watch. There you go. Did you see the plasma ring go off the sun? I think those are incredible. You actually get a smoke ring coming out of the sun. But this is speeded up, obviously. You can see the stars in the background. In a minute, you'll probably see one of the planets go by. But this is basically the sun rotating in 27 days. And you can see it in stop motion up here. You can see it starts out, you can see the magnetic field lines are out and the flow is outwards. Then you see this big bulge presumably from a solar, from a sunspot on the sun, a pair of sunspots, and you can see the prominence. And then if it expands outwards, it gets really big, it just basically blows open and you get this gush, as you can see down here on the left, you can see this gush of plasma that comes out from the sun. Now, looking down on the sun, and this is what's important, you'll note the red and the blue are in and out magnetic field lines. This is looking down on the sun in the ecliptic plane. And when one of these events occurs, you can see how it expands outwards. You can see the coronal mass ejection coming out, and the Earth is down over here. I happen to be more concerned with Jupiter and Saturn and myself. So I spend a lot of time worrying about these for out there. That's why you see this scale size. But you can see how the cloud expands outward and strikes Earth. These lines are the magnetic field lines. There always has to be an equal amount of magnetic field coming into the sun and an equal amount of magnetic field going out. Otherwise, we would have monopoles. And that would be very exciting, but we don't. Now, this is going to show you what happens at the Earth. When that plasma cloud reaches the Earth, here it comes. That gray flapping, forget that. That's a artifact of the People's Magnetic Field Model. But you can see what's happening in this little inner region in here. This is what it looks like on the average. This is the magnetosphere. It looks like a big comet tail stretching back in here. This is the region where the two regions we're most interested in is here and here. Very high energy particles from solar flares. That's million electron volt, protons, electrons, heavy ions, typically would come in this region here, what's called the cusp, which is where the magnetic field of the Earth has been dragged back. There's a little opening. That contributes somewhat to the atmospheric heating. The big effects are twofold. One, there's an electric field. You see down here, it says neutral sheet current. That increases and decreases as the plasma cloud goes by the Earth. And depending on how intense it is, it can smash or crush watch it like there. See it smash the magnetic field down, the magnetosphere down. And when it does that, it creates a huge electric field across the polar caps, which drives currents in the atmosphere, which heats it up. It also pushes in, you can see this tail. This is a dense plasma back here, cold plasma, like 20, 30 kilovolt electrons and protons. And they get pushed into the Earth and cause the aurora. Now over here on the left, you're actually looking at this event that was being modeled down here. You're looking at satellites, GOES 6 and 7 out at geosynchronous orbit. And you can see from the magnetic field measurements on these satellites, this is the Earth's magnetic field. And suddenly they're out in the solar wind, they're back in, they're back out as these two, the plasma clouds go by the Earth, as you can see here. So this is a simulation showing what was actually measured at the Earth of the big compression of the magnetic field and the result injection of plasma. Now, what we saw for the Starlink, as we'll see, we're not nearly quite as dramatic. There's a smaller version of what we're looking at here. But what happened, this is the sun over here, and you can see the aurora that are created by that plasma coming in along the magnetic field lines, and you see you'd see a companion to this, an identical inverted companion in the southern hemisphere. This is the auroral zone. This is how roughly how often you can see them as far down as Mexico City, like 1/100th of the time. They'll actually push down there. That was 1972. They actually had saw the aurora in Mexico City. Over here, you can see the probability as a function of geomagnetic latitude. It's the magnetic field of the Earth is offset about 11 degrees. So this, if you add 11 degrees to this, you can get an idea but roughly where it was. It will run from 86 down to 50, where the peak occurs. But this is magnetic local time. Typically, you see these plasma events, intense aurora, as you can see over here, at near local midnight. And you can see this is the probability of occurrence. It's actually fairly small. It's like 1/4% of the time would you ever get one of these huge auroral events. But we get them, and when they happen, they really cause the atmosphere to expand greatly. You can go up to a factor of 10 to even 100 times in the space of a few minutes, and literally knock satellites out of the sky, as we'll see in a moment. Now let's look at the physics over here. Let me get up here and just crush down so I can see what I'm doing. If you look on the right, this is a typical atmospheric profile for the Earth. This is in fact, this is the average atmospheric profile for the Earth. I call your attention to two issues. Down here, everything comes up, drops off exponentially, and then suddenly it changes and drops off exponentially for each component differently. Below 90 kilometers, there's enough collisions between the atoms in the atmosphere that they're very thoroughly mixed. It's homogeneous. And so this is called the homosphere down here. And then up here where it gets separated, it's called the heterosphere. So above 90 kilometers, the atoms don't see each other. They basically miss each other. There are very few collisions. So down here, below 90, where we live, it's typically 78% nitrogen, 18% to 80%, 18% oxygen, and O2, and then all this other stuff down here, diatomic oxygen and diatomic nitrogen. Above that, it transitions to pure oxygen above about 500 kilometers, and then above about 1,000, it becomes all pure hydrogen, and you can see them. Let's see the differentiation in the species. Here it's homogeneous, here it spreads out. What we're worried about is the region in here. Now, let me explain to you why it falls off exponentially. This is the so-called hydrostatic equilibrium equation up here. We start with a simple equation that the pressure times the volume is equal to NKT. Now, what then happens is that if you go back. If you solve across, you can divide by the volume into the total number of particles. You get number density. So you get the pressures equals the number density times this constant times the temperature. And inverting that, you get that the number density is equal to pressure over temperature. Now, the other formula that we need is force. The pressure is equal to the pressure, I'm sorry, keep hitting it wrong. The pressure is equal to the force per unit area, as we all know. So for the atmosphere, what we work out is we take a volume of atmosphere, that's shown here, to get the force, and that's mass times acceleration of gravity, mass times acceleration, mg. The mass is given by the mass of the individual particles, the number of those particles, times the area times the thickness vertically. So this is the volume times the number density gives you the total number of particles times their average mass. That gives you mass times g, mg over a, and where dx is the difference in going up and down in altitude. We'll solve that over this, take this equation, punch it in here, and you get that dp is equal to p times this. Rearrange the equation, integrate from the ground pressure up to some altitude, 0 to h, and you get this. This explains why the atmosphere is in what we call hydrostatic equilibrium, the first order. It drops off, I want to stress, exponentially, and it's a function of the temperature and the height that you go up. Now, if you change this temperature, the distance over which the atmosphere falls off increases. And so the density can go up. We can also replace this with number density. So that would be N is equal to N naught times this. And this is the mass of the individual species above this altitude. So that's the scale height over T. mg times kt is the scale height times h. And so so as you go up in altitude, the scale height can change with temperature dramatically with geomagnetic activity. So what are some of the effects of changing the atmospheric density with height? Well, first of all, the one we're going to study today is drag. Another one that is very annoying is called glow. The surfaces in the direction in which you move in space at low altitudes actually glow with an orange glow that looks like this. Astronauts can see this. Oh, and Garrett told me he could almost read by it on the Skylab when he went outside. So this is rather dramatic. I have another in my course I teach, I show you films and stuff of this where the astronauts film it out the window, and it's quite dramatic. The other one, the one that we really get irritated about other than drag, is that surfaces, particularly plastic surfaces like Kapton, will erode. This is, on the left is the original surface. This is after a few months on orbit. Actually, this is from shuttle when it's a few days on orbit. You can see the surface is eroded away. We have, for example, on the LDEF satellite, which was up for 5 years in this region, whole surfaces were on the front of the vehicle were eroded away. So those are the three major effects. Of course, today we're more interested in drag. Here's the basic equation for drag. I think you're probably all aware of it, but the bottom line is that the force from drag is equal to roughly the kinetic energy, this area times the density, this is the areal density, the area in the direction you're moving, 1/2 mv squared, and times this constant, which is called the drag coefficient. Now, the problem you have here is we don't really know the drag coefficient, and we don't really know the atmospheric density that well at any given moment in time. So you can get your subject to lots and lots of surprises. Now, one of the things I want to point out is that when I was early days back in the 70s, when I was in the Air Force, we were interested in knowing how low you could go in orbit. So what we did was we built a couple of satellites built out of depleted uranium, so we could, and with reflectors on them so we could track them. Put them into orbit. They were about 1 meter across, and we fired them at increasingly lower altitudes. We got down to 90 kilometers and could make one complete orbit. And those were called the musket ball and the cannonballs flights. And our little humor was, it was called the shots heard around the world, as just one complete thing. I've done this here for you for the shuttle. Now the shuttle has a drag coefficient somewhere in this range. It had if you flew it in the least drag, you get 50 square meters. If you flew it base on with the worst possible drag, with the bottom of the shuttle flying in the direction you're going, you get 400 square meters. The velocity at about 400 or 500 kilometers is orbital velocity ranges upwards to 7.6 kilometers per second. This is the atmospheric density down here in grams per cubic centimeter. And when you work that out, you get very large drag shown down here in terms of dynes for the space shuttle. So just to give you an idea of how you calculate it and what it looks like. Now here's one of the key charts today. What we've done here is we calculate for circular orbits and for a representative, what they're called Explorer series. The Explorer series were a few square meters, a meter or so across, and so it's a couple square meters, roughly the size of, same size as the Starlink satellites, as you can see. And so we can use this. Unfortunately, the chart doesn't quite go down a lot. We would be down here if we were worried about the 200 kilometer orbit that those satellites were in. But you can see what you look at. This is the F10.7 index. I digress for a moment here. One of the other things that the sun does is it puts out extreme ultraviolet. And the ultraviolet radiation heats up the upper atmosphere. And it's one of the other drivers of the density. As you can imagine, on the sunlight side of the Earth, EUV heats up the Earth. You get a peak around 2 o'clock in the afternoon at the subsolar point. And the Earth, of course, as you turn around, you go into nighttime, the density drops off dramatically as the EUV flux goes away. So one of the things we need, one of the indexes that's important to us is this F10.7. What we found out many, many years ago, back in the 60s and 70s, was that the atmospheric density, for some reason, responded to the EUV flux, apparently almost identical to the way the 10.7 centimeter radio wavelength line worked. So we went through and we looked at the radio emissions from the sun, and we found that 10.7 centimeter wavelength correlated the best with the EUV output flux. So it's very easy to measure the 10.7 centimeter. So for many years, rather than measure the actual EUV output from the sun, we measure the 10.7. As you can see down here, you go from 75. It's typically for low values down around 50 over here, or at night it's nothing. But what happens is you can see this is the number of years at which it takes for you to decay. So at 75 index, it takes you about 3/10 of a year, so 3 or 4 months to decay. At 300 kilometers, 300 kilometers, it takes you to decay. Whereas if you're over here at 250 10.7 or extreme a lot of EUV flux, it can take less than a month to decay. And obviously, as you go up, it takes longer and longer to decay. And by the time you get up to 800 kilometers, you're talking about thousands of years, or maybe 100 years if the atmosphere is extremely active. So you can use this chart for quick and dirty estimates of where your satellite's flying. Now, this becomes important to the space debris issue because they have to show that the satellite will decay within a certain length of time. I think it's, what's the latest? I think it's 20 years. They're about to change that because of, about to change that because of the Starlink and people like that. Can you imagine 30, 40,000 satellites up there for 20 or 30 years? So I think what you're going to find is they're going to change that number shortly. But the bottom line is that you want to get up at least, you want to get a satellite down below 300 kilometers so it'll decay in if you're in low Earth orbit. And that's become a requirement on many of the satellite constellations, is that they have to either be able to move them or show that they're going to decay within 20 years. Now, here's the winter chart. This is from that March storm I showed you, from that really huge coronal mass ejection. The NORAD, what used to be NORAD, the people for the Air Force would calculate, follow the satellites. They still do, but they changed their name. Anyway, the old NORAD, as it was called, produced this chart. And what it is it along the bottom, it's the date in March 1989 when that storm occurred. You can see it occurring right here. This is the so-called AP index. AP and KP are two measures. They're directly related. One's logarithmic, one's linear. AP is linear index. Indicate how much the magnetic field of the Earth is disturbed at mid latitudes. It's I've helped calculate it myself for them on a number of occasions. And basically, you look at the magnetic field of the Earth, calculate how much it deviates from its average value, assign that a number, and that gets this. And they every 3 hours they put this index out for the world, the so-called KP index, and the little AP index. The capital AP index is for the day. It's the sum of the of values for the day. As you can see, on around the 10th, there was a sudden increase in the geomagnetic index. And after that, these bars that you see are how many satellites they lost track of at low altitudes. In other words, they're following it, they got the orbit, everything's pretty good. And typically out of 10,000, 20,000 satellites, on a good day, only about two or 300 are low enough that the drag is causing them not to know exactly where they are. But all of a sudden, within a space of a day or so, we went from 200 unknown satellites to over 1,400 satellites. And as time went on, as the atmosphere quieted down on the right, you can see they went back to being able to track the satellites. That's basically what they do, and you can understand why they do this, is they track each one of the orbits of every satellite up to, like I say, about 10 to 20,000 these days. And there's actually, if anybody's interested, I can provide you the websites. You can go in and find out where any given satellite is at any given time, provided that this hasn't happened, because they lose the orbit fails. So now let's look at what was actually going on in the day of the Starlink. Bottom line is this: on the lower left over there, on February the 2nd. Anything below about KP or K index of 4. I'm sorry to keep throwing all these indexes at you, but the little KP index is the 3-hour index. The big planetary index is called K, which is made up of the KP, and there are 3-hour indices. And like I say, in my big course, I go into detail on how you calculate it, but that's not important to you right now. The big thing is, notice that it's down here in the green and the yellow. There was not much magnetic activity. Then a little on the 3rd, there was an event. Presumably, that was was related to one of that coronal mass ejection that we've been talking about. That's over here on the right. This is a picture I took in my backyard on the 5th, the same day that these happened. You can see a prominence down here on the left. Right here, you can see the prominence I took a picture of. These are sunspot groups, and over here, as a few days later, I downloaded the picture for a different wavelength. You can see that hole there is the coronal hole that was probably associated with the coronal mass ejection that came out from the sun. And down here, you can see aurora from right at the same time, within a day or so of this event. People took pictures of it. So this is on the right is the actual pictures of the sun and the earth, showing the aurora and showing the flare and the coronal mass ejection that took place. On the left is the ground-based magnetic field measurements. And here is where the storms that caught the Starlink occurred. This is where the coronal mass ejection hit the earth. They'd been on orbit for a couple of days, and then they were hit here. And give you so you can get an idea of what was going on. Now, this is the fascinating chart up here on the left. Up here, the red dots are what we call apogee. That's the farthest distance from the Earth of the satellite. Down below is the blue ones are the perigees. Notice these pretty much fall in real close pairs, because what they're doing is they want to put their satellites in close orbit, so the perigee and apogee are very close. They start out at these low Earth orbits, and then they apparently move them up to about 500 kilometers or 400 kilometers. So this is what they're doing. This is their initial launches of their that they've done so far. And lots of these are like 40 or 50 satellites. I think they're up to 10, about 2,000 or 3,000 right now. Whoops. So they're building up their thing, and this is where. Oh, come on, where's my point? There. This is where they launched recently, and you can see that the perigee is down there around 200 kilometers. And if you look at the two figures below that, you can see the F10.7. Look at 2022, you can see the sudden peak in the F10.7 going up to 150. And that happened over the course, as we've seen, of a couple of days. The net result of that is that when these things came down to perigee, their orbits suddenly hit a wall of atmosphere, and basically the satellites fell out. And that's a picture of one of them falling out on the right up there. The people in Puerto Rico, one of the sky cameras actually caught, there's a movie that you can look at the reference up there. If you go to that site, you can actually see the thing come in, and these are the debris splattering into the atmosphere. And so this gives you an idea of what's happening. Now, to summarize what I'm trying to talk, what I wanted to talk about today is basically space is not empty. The upper atmosphere is not empty. Certainly below 500 kilometers, drag is a serious and critical problem that needs to be considered in everything. Not that they did not take that that the SpaceX people didn't take that into account. What happened was they were only going to spend a few days there, check them out, and then move them up to the higher orbits, up to their a higher apogee perigee. Unfortunately, they didn't get a chance. What they probably should have done is looked at the geomagnetic activity. The sun has started to become very active now, and they're going to have to move their perigees up if they want to be able to continue doing their process. The one good thing that came out of all this is that apparently their satellites can fall down like a rock if you move them down below 300 kilometers, which is good given that there'll be 30,000 up there. So the conclusions is basically monitoring the environment, everything from the sun and the solar activity. Fortunately, like I said, there's about a 4-day lag, so we get some warning. And right now we're putting things out at the L1 point out in front of the Earth. We can get about an hour or so, very good estimate of what the solar wind that's coming to hit us is. And then the next thing is the real problem here. There's going to be a talk at by AIAA and JPL with the people from SpaceX on this issue in a couple of days. Or next week, I think, by that lady vice president. Hopefully they'll discuss this. They're putting up so many of these satellites, and other people are racing to put up almost as many in low Earth orbit, that the likelihood of us running into things is almost catastrophic. And there's a thing called the Kessler syndrome, where once the satellites start hitting each other, that it goes exponential, the growth of the debris and things like that. Satellite blows up, causes debris, that debris causes other satellites to blow up, and it's like within a few years, the whole thing forms a shell. I've always felt that perhaps one of the ways that we look for space aliens is to see if they have a shell of debris around their planet rather than a ring like Saturn. So my final point is that educating spacecraft designers and users in the effects and mitigation of space environments is critical. For many years, I've taught a course throughout the NASA, the Air Force, and IEEE on space environments and effects, and tried to spread the word out there. Just to conclude, some of the books I've published up on the left was the one back in the 80s with the AIAA. I put together conference proceedings, and that we actually had the first paper on the Kessler syndrome. Don Kessler published it in that book. The next one down is the course that's taught at MIT that Daniel Hastings and I wrote. That's the course that he teaches on space environment effects. And on the lower right is my latest book on how to mitigate spacecraft charging effects. That's it, I'm done.
Thank you so much, Dr. Garrett, for that highly insightful speech.
I hope it was understandable.
No, it definitely was. I tracked, and that whole issue you brought up with just the amount of satellites that we're putting up in low Earth orbit. That's what does this mean for future space missions or
duck?
Yeah, that's concerning. It's I saw from your depiction there, and the web of satellites that essentially will form. It's really the upper and lower poles seem like the only access points, entry.
My last talk for Ken, I talked about this, and I have a movie. It looks like a beehive around the Earth. It's really frightening. It's 40,000 pieces of junk above 10 centimeters. Problem is we can't very well track anything below 10 centimeters, and 1 centimeter will put a hole through your entire satellite. So it's bad.
So I have a question here in the chat from Selin. What do you think about the efforts to track satellites much better?
All right, I've had a lot to do with that over the years, and some of my friends are currently the leading experts in that area, and I keep in touch with them. What we do nowadays is we have a variety of atmospheric models that we use that we try to run in real time to calculate all the energy inputs and the composition. I helped develop some of the first ones, the most popular one, the AIAA model. I worked on that one with him. And that's what you saw was the output from that model. But nowadays we have dynamic models. And the first step was to try to get them in real time and then predict. The latest thing we've been able to do is because there are enough satellites up there and that we track certain reference satellites, we can actually do in situ measurements. In situ measurements coupled with the models gives you about an order of magnitude improvement in our ability to produce, to represent the density in the atmosphere. And that's what they're actively doing now. And for the Air Force and at the now NORAD, whatever it was, to do their orbit calculations. And it's made a significant, Frank Marcos is the inventor of that. And that's been a major improvement in satellite drag calculations. The problem still goes back to the cross section of the drag coefficient. And I didn't point out, I meant to point out that one of the solutions to the drag problem is not making the area smaller, but putting uranium on the satellite, making it really dense so the drag goes down. If you notice the equation, it's inversely proportional to the mass. So.
And you mean just lining the actual structure itself, or
no? Just put mass in it.
Mass.
More massive, the smaller. You keep the same cross section, but just put uranium in the middle of it. That's what they do. But the people put lead in them.
Wow.
What they want to go low, because there's a lot of excess launch capacity to low Earth orbit. You have a lot more energy. So if you put lead in the things, I don't know, Starlink ought to start putting lead in their satellites.
Great. Again, if anyone has any questions, please drop it in the chat. But yeah, so that's, again, highly concerning. And well, I'm glad people are, looking at this and making sure nothing too bad happens. But I think Gennaro has a question for you.
Okay, what's the question?
Dr. Garrett, so there's this company called Morpheus Space that's working on an electric propulsion system to increase maneuverability for satellites. So do you see potential opportunity there as well?
Yes, in fact, I worked with what is it now, Northrop Grumman, bottom out. They're developing systems where you actually go up and connect an electric propulsion system to the satellite, and it's already was done. We at JPL worked with them because one of the problems is with electric propulsion, you have to couple to the satellite, and they were extremely worried about the fact that they short out when they connected and blow the satellite out. And so what we did was we worked with flooding space with plasmas. Fortunately, ion engines flood space with plasma, and you can neutralize that effect. But there are lots of things like that, lots of issues that you have to concern yourself with when you go to plug the electric system into the other satellite. But no, satellites are starting to be built with ability to be refueled and lifted back up to high altitudes or to bring them down. It turns out that the only strategies we have right now are to get them to low Earth orbit or put them into parking orbits. The one we most worry about is geosynchronous. And because think of it, the velocities aren't that high, but if you blow up one satellite in geosynchronous orbit going the other way, everybody's in one orbit. So that's what I did when I was at Star Wars. I figured out how to destroy satellites. I got all kinds of ideas, and you need to know them. My favorites: you go up to the satellite with a can of spray paint and spray it. The sensors.
That sounds effective. Okay. Well, thank you so much, Dr. Garrett. Thank you so much for your presentation. I appreciate it a lot, and I'm sure everyone did here as well. Thank you.
Okay. I guess the last thing to tell y'all is I grew up in a small town in New Mexico on a small Air Force base called Roswell.
Nice.
I was born 9 months after the landing. All right. I'll see y'all.
Thank you, Dr. Garrett. Thank you so much. Okay, moving on to our next agenda item. It's time for our university presentations. Just to recap, so the AIAA LALV professional section has 4 different universities under their jurisdiction. UCLA, CSULB, UNLV, and USC are the universities that fall under the LALV professional chapter. Again, this conference is for them. We want to engage with students. We want to bridge the gap between the professional members of our chapter and the actual students. That's important to me when I was a student. So that's why I attended these mini conferences in the past, as I mentioned. But I'd like to begin with UCLA, the UCLA student branch. They're going to give a quick 15-minute overview about their chapter. So I'll hand the floor over to Celine.
Hi, everyone. Are you able to hear me? I assume.
I can hear you, yes.
Okay. I am the current president of the UCLA chapter of AIAA. We are, actually, next slide, please. I don't have slide control. We are a professional aerospace society. I mean, we're all AIAA chapters here. But as the UCLA chapter, we focus on professional development. We also focus on academic support, and our main focus, and what I will hand off to some of the project leads today to talk about, is our technical projects. We have a goal here, and I hope that all of the other student chapters share this goal of allowing anyone who's interested in aerospace, regardless of their major, regardless of their prior experience, also regardless of, age, gender, all of that, to pursue their dreams and to see if this is the profession that they want to end up in later on in their career. Next slide, please. This year, we have tried to carry out this mission through a couple different virtual and hybrid events. UCLA switched back to in-person instruction in the fall, and then decided to return to virtual instruction for the first portion of winter quarter, and now we are back in person again. The MAEX MSc Career Fair, which stands for the Mechanical and Aerospace Engineering and the Material Science Engineering Departmental Career Fair, is put on by us and a number of other student clubs within UCLA, more specifically within those 2 departments, the MAE and MSc departments, in fall quarter. And this year we did a virtual career fair to accommodate the different companies that said that they were doing virtual recruiting. And that was a pretty successful event with, I think, students getting some good experience talking to recruiters and hopefully also some jobs out of it. We also have company info sessions that we have put on in the past in collaboration with companies, and we've gone out to companies to do tours. That has not worked out well this year, but company info sessions still continued. We also have the mentorship program and the professional development series. Through these two programs, we're trying to make sure that students are, as the title implies, getting enough mentorship, and also developing their resume writing skills, their interviewing skills, learning how to write cover letters, learning how to do a technical interview, stuff that most of the time we're not taught in classes, but we do need to, get into industry and get into possibly also academia. Class planning and help is also a big part of it, where in the ME department, at least, it's pretty set, but students can kind of see where they're going with their next couple of years or even the next quarter. And then the K through 12 outreach is something that our projects have taken up on different levels, and they'll be talking about that independently. So I do want to pass it off to next slide, please. Our first technical project, which is design, build, fly, and I believe we have Sihar or Paul talking about that.
Hi, yeah, so I'm Paul. I'm a lead for DBF at UCLA. You can see our first prototype in the air from this year. So at DBF, we have three main missions. So we want to promote applying the engineering skills that we learned in classes and knowledge from classes to real world situations by building a plane. We also want to give students a space to develop these skills in both technical and leadership skills that will they can carry with them going into the professional or research fields. And then each year we represent the UCLA Samueli School of Engineering at the AIAA DBF competition. So competition each year involves 100 or more teams from across the nation and across the world, either in Tucson or Wichita. So this year it will be in Wichita, Kansas. So each year the competition rules change, giving us a different design challenge and giving us a chance to solve some new interesting problems. We'll talk about, I'll mention some of the other planes in the future, but so this year competition is focused on creating an aircraft that can carry syringes and deploy vaccine vial packages that have 25 G-Shock sensors in them. So we have to find a way to lower the packages onto the runway as well as land softly. So we have a number of constraints. I think the largest constraint for us is the max takeoff distance and the battery energy. And so we'll have 4 missions to show the plane works, show that the plane can fly, carry vaccine vials, and deploy vaccine vial packages. So this year, we built 2 prototypes, had a number of fly days. So now we are manufacturing prototype 3, our competition aircraft. So hopefully we'll test that next weekend and make some improvements from what we've seen in the first 2 flights. So looking at our schedule, kind of for this calendar year, we've finished most of the design phases, submitted our design report last week. And now we're working on testing and finishing up design of mechanisms for deploying packages. So as Celine said, we kind of want to be able to include everyone each year. So we have kind of 2 main ways that we do that. So we offer a small class every year that gives people a chance to get school credit for building a plane in a class of over a quarter. So I think they flew yesterday as it's the end of the quarter. We also offer at the start of the year a 6-week training program, knowing that a lot of people don't have any experience with planes or designing engineering projects. So we have a number of lectures, 18, to introduce students to what we do and a lot of engineering skills that are useful both in the club and in industry. And you can see here our social media platforms and some of the variety of planes that we've designed. I think most of them over the past 7-8 years, a lot of different planes for different projects. And next up is Rocket Project at UCLA.
Hi, everyone. I'm one of the project leads in Rocket Project. So essentially, our mission is to build the next generation of aerospace engineers through education, achievement, and rocketry. We have two flagship teams. So we have Prometheus and Ares, and both of them aim to design, build, and launch one rocket in one academic year. And we also have a wonderful outreach program where we set up outreach events for kids in the local community. We introduce over 130 new members to rocketry each year. So here's our project growth. So in 2013, 2014, 2015, 2016, around that time, we only had about 30 active members. And our team was working on a COTS, or commercial off-the-shelf hybrid motor rocket. And we would have about one launch per year because we had one main team and two hot fires. Over the past few years, we've grown a lot. We have almost 150 active members now. Our flagship team, Ares, they build and launch a liquid propulsion system rocket, and Prometheus, the team I'm project lead of, builds a hybrid propulsion system rocket. And we also have a new member education program, which I'll get into a little bit more. And we partner with the MAE department. Professor Spearin is the head of our lab, and we have about 15 hot fires a year, which is a pretty large amount, and about 3 launches per year as well. So here's kind of how our project pathway works. So all of our rocket project members start in E96R, which is a class similar to like the DBF class, where new members and anyone honestly at UCLA can come and get the chance to learn how to build a small high-powered rocket. And then from there, they move into Prometheus, which is our new member team. We compete in a competition in New Mexico, and we build a hybrid rocket, meaning we have a solid fuel and a liquid oxidizer. And then lastly, we have Ares, which is kind of our flagship, like record-setting team. They fly a liquid bipropellant rocket, and it's a pretty advanced system. So that's why we have Prometheus to kind of prepare them for the challenges of Ares. So this is a little bit more about our education, our E96 class. So it's an undergraduate talk class. So all of the teachers are just members of Rocket Project who have gone through the entire cycle of Rocket Project. And so we offer 4 sections. They fill up really fast. It's a pretty popular class. Students have the opportunity to launch 2 of their own rockets in like a group setting, and they get a chance to learn about Rocket Project, learn about rocketry, a lot of the science behind it, and kind of learn about more about opportunities in the aerospace industry. And also they get the chance to decide maybe what subsystem they're interested in. So if they want to do vehicle engineering, electronics, or propulsion when they join a Rocket Project team. And no experiences are required. Pretty much all of our members that come into Rise and Prometheus have absolutely no rocketry experience. So we definitely welcome everyone. So we have Prometheus, which is our hybrid rocket team, as I said before. So it's completely made of new members. We have about 85 members this year. Almost none of them have ever worked with rockets before. So it's a really awesome learning experience. We compete at AIAA, which is like the Spaceport America Cup in New Mexico. So we're going to go be down there June 21st to 25th of this year. Last year, we successfully launched our Osiris rocket, which you can see on the left here. We had been able to manufacture the entire rocket in under 10 weeks because we had we only started manufacturing a little bit into spring quarter because that's when we got lab access. So that was a pretty big accomplishment for us last year. And then Ares, which is our liquid bipropellant team. So they compete in the Far Mars Challenge, which is held by Friends of Amateur Rocketry in Mojave, California, which is also like a location that we launch at. So they have a goal of launching a rocket to 45,000 feet. This is also outlined with the competition. And they currently hold an altitude record for a student-built liquid bipropellant rocket, which is really exciting. It's at 19,000 feet. So a little bit more about Prometheus. So as I said before, we design and build a hybrid-powered rocket. And one of our main goals is to prepare our members for the challenges of Ares, as it's much more complex and a larger system. So all of our leads on our team, we have sub-team leads and we have component leads, all of them are new members. So we give them a chance for like leadership experience and the chance to like have responsibility for a part of the rocket and gain a lot of experience that way. And obviously it's a little bit hard to build a rocket when you don't really know what you're doing. So we have a lot of direct mentorship and guidance from older members. So just a little bit of stats about Prometheus. We had about 12 hot-fire tests in the past 3 years. We finished in second place in IREC, which is a pretty large competition, in 2018, and we have about 85 members. So Ares, they're dedicated to building, again, the next generation of rocket engineers through the design, build, and test of a liquid bipropellant rocket, which is often what is used in industry up to 45,000 feet. So to answer the question in the chat really quick, a rocket is not entirely 3D printed. We definitely have some elements that are 3D printed, such as our electronics housing, and a lot of the times when we do like fiberglass layups, for example, for our nose cone or like boat tail, we'll use a 3D printed mold. But a lot of our rocket is made out of like composite materials, such as like carbon fiber. We use a lot of like graphite, metal stock, and all that kind of stuff. Yeah, we have access to the wonderful makerspace at UCLA where we can go and 3D print things for free, which is it's a great resource. So Ares focus on a 1-year timeline, which is a pretty tight timeline for such a complex rocket, but we build all our own engines. We call them an SRAD, so student research and develop. So there's a lot of great experience to be had there. And they have about 50 members, and we're one of only 7 universities to build this liquid bipropellant rocket. We also have an R&D part of Rocket Project dedicated to trying projects that could make our rockets better. So we have a gimbaled thrust project, control surfaces, and a turbo pump under R&D. And lastly, we have our STEM outreach. So we have an outreach team that kind of puts on events at local schools in the LA area. And over last year, we started doing virtual outreach. So we would film videos and go to schools, make like virtual visits to school. And this year we're doing a little bit of both. We have virtual visits and in-person visits, and it's a lot of fun. We encourage all our members to sign up and try to go to outreach events. Yeah, so here's some pictures from outreach events. The kids really have a lot of fun. It's a good time. Yeah, that's it. Here's UAS.
Hey everyone, so I'm David. I'm the president of UAS at UCLA. We're the main drone club on UCLA campus. So our mission, there's a couple. One's to drive innovation in the field of uncrewed aerial systems. The second's to have cross-disciplinary collaboration. So we get a lot of members from different fields. I'm actually a CS major myself, which is probably a bit unusual for the AIAA branches. So we get a lot of CS majors, a lot of different majors, and have more of an emphasis on controls algorithms and figuring out different algorithms for flying vehicles. And then our third goal is to be very hands-on. So we tend to, when we get new members, we assign them to a role on one of our projects. We don't usually have a really long training process. So our goal is kind of get people working on something impactful as quickly as possible, and then give them an opportunity to learn while they're working on an actual like full system. So this year we're working on 3 different projects. There's the AUVSI SUAS competition. This competition, there's around 25 to 30 different members competing in it. And it's made up of 2 main teams. There's an airframe team that works on the overall design of the drone. And then there's another team that works on all the software for controls and taking snapshots, doing various tasks in the competition. The second thing we're working on is the NASA Aviata Research Challenge. And this is like a proposal we made for an 8-drone hybrid system that we submitted to NASA last year. And then this year we're finishing up that submission and our paper on that. And then the last one is a newer competition hosted by IEEE in Purdue. And this is more of a software-based simulation competition with a final stage that takes place at Purdue itself with some real drones. So yeah, so we'll just dive a little bit into all this. So the AVSI SUAS competition, this competition, it's a search and rescue mission. So you can build any unmanned aerial vehicle. It can be a plane, it could be a drone. There's usually around 60 colleges that compete. And this happens the end of each year. Usually for UCLA students, it's a week after finals on the Naval Air Force Base in Maryland. So this is a pretty involved competition. There's a lot of different subtasks to it. In addition to building your actual vehicle and having to navigate autonomously to waypoints, you also have to avoid moving obstacles. This year they added a new task, which is you have to scan a different target area and actually generate a map of that area. Before that wasn't a thing. And then there's a uncrewed ground vehicle you have to deploy to deliver a payload. They've added some extra tasks to that this year. So at the bottom, we just have like kind of a breakdown of our different submissions. So in 2018, 2019, we had our drone Spinny. That was one of our earliest entries to the competition. 2019, 2020, we decided that we were actually going to build a plane that year. So we tried out building a plane, but then the middle of COVID happened. So this year we decided to go back to a drone design. So you see our latest drone on the very right, and there were some pretty large improvements over the past one. The main thing is the overall design is just more robust. We simplified a lot of the different mechanisms, and there's also a different co-processor and better landing gear for this year's design. So that's an update on that competition. So NASA Aviata, this is a research project. So we proposed this last year, got it. It was a UAS member proposed it, wrote up the proposal. We got some money from NASA to actually pursue it. And last year we were able to get like a pretty okay proof of concept. This year we've mainly made progress on getting the controls of the system to work together. So the main idea here, you can see kind of in the right corner, basically there's one central payload and all the drones attached to that central payload and then fly as one entity. And so the main cool thing about this project is the goal is to have 8 drones at some point all fly together, and then mid-air up to 2 drones can detach and 2 new drones can attach. So as far as like a status update on that now, right now we're just continuously iterating on the 4 drones flying together. So we had like a rough proof of concept of that last year, and then we've made some pretty major strides in the controls algorithms for the yaw controller and different aspects of all the drones this year. So we're hoping by end of this quarter, start of next quarter, we'll have the 4 drone system completely flushed out with attaching the drones to the frame and detaching. And then maybe end of the year, we'll have the original 8 drone proposal all done. And then our last competition, so this is a newer competition. It's one of our smaller competitions. So we have around like 8 members who are competing in this one. And this is a mostly software-based competition. So the task is essentially there's a moving vehicle and you create drone software that tracks the moving vehicle and navigates through a bunch of obstacles and a miniaturized cityscape environment. So the start of the competition just taking place right now. It's mainly in Gazebo, which is just a simulation environment. So you just have a drone fly through tracking the vehicle. And then if you proceed through that part of the competition, then there's actually like a miniaturized cityscape set up at Purdue that you can test out a real drone that they provide you with some of your algorithms. So those are our 3 competitions. And the last thing we want to talk about was we also have the E96 course. So this is a course for new UCLA students. Because we kind of have students just dive right into building things when they join the club, we also wanted an opportunity for students to get more of a learning process, just a total introduction to drones and everything about them. So this is a course that we started teaching this year. We've had it for 2 quarters, fills up pretty fast. It's been wildly successful, so we're really happy how that's going. And this gives students opportunity to design drones, learn about software, CAD, all the different elements that go into creating a flying vehicle. So yeah, that's it for UAS at UCLA. And I'm also the last presentation, so that's the conclusion of our AIAA at UCLA presentation, unless Lynn wants to add anything else. And you can contact us here.
Just want to add really quickly, I'm excited to see what the other not UCLA branches, AIAA branches are doing, and our contact info is there. But we hope to have a bigger presence in the LA LV AIAA conference overall, or organization overall. Thank you.
Thanks UCLA so much. It makes me so happy to see just the level of involvement you all still had during the pandemic, and your projects are just amazing. One thing I want to understand is, so you all have integrated your different projects into an actual UCLA course?
Yeah, so I'll answer really quickly. The UCLA E96 courses are designed to be introductory, low unit, low stakes courses that are like, I think Anjali mentioned, student-led, student-taught, and they're usually curriculums approved by the School of Engineering, but the curriculums are created by the clubs themselves to provide the students that are interested broader introduction and some experience with that topic or that whatever they're doing. There's also ones for example, like our formula team puts on one that's more geared towards cars or like a Baja vehicle. We just happen to have ones that are plane, drone, and rocket related.
So how effective do you think that is in generating interest in students and then transitioning from the course to the actual chapter?
So I don't have official numbers regarding student enrollment, but since we've had those courses, I think the number of students that have been interested and been able to translate that interest into involvement into the organizations has increased. And we've also started to get, I think, more students that wouldn't traditionally commit to this sort of a club, for example, non-STEM majors, or students that see it on the schedule of classes think, oh, well, why not? Why can't I just add this to my first year, first quarter, second quarter schedule? And the grading is not hard. It's not really meant to be academically challenging so much as just to have people get their hands on something and see what it's all about.
Gotcha. Okay. Well, thank you so much, UCLA. Thank you for your time and keep up the great work. Moving on to the Cal State Long Beach presentation. I want to hand the floor over to Michael and Kenny. Thank you.
Hi, thank you everyone for having us. My name is Michael Nightingale. I'm the vice chair from AIAA, the student branch at Cal State Long Beach. And this is just a brief overview of what our club's been up to in the last year or so. Can everyone hear me okay and see my screen?
Yep, you're good.
Okay, thank you so much. So our mission is essentially to advance the arts, sciences, and technology of aeronautics and astronautics, and to promote the professionalism of those engaged in these pursuits. We encourage original research, student projects, professional development, as well as education. And we'll get into the specifics as the presentation continues. So today I'm joined by our treasurer, Kenny, and our AESB rep, Sean Dow. Unfortunately, our chair, Hunter Lewis, tragically passed away over winter break, but we feel it's important with all the work he's done to remain in our chair, and hence why I'm very proud to be his vice chair for the rest of the semester. So I'll turn it over to Kenny.
So this past semester, with school being online, we provided network opportunities via Zoom. And from the fall semester 2021, we had 6 guest speakers from companies like Northrop Grumman, JPL, Aerospace Corporation, Aerojet Rocketdyne, and SpaceX. And each presentation gave us a unique and different presentation. And we also had a resume workshop with Northrop Grumman for the fall 2021 semester. And now with COVID restrictions being lifted, we hope that we can continue to have these professional speakers in person, and also be able to have the industry tours that we used to have, like the Northrop Grumman tour in 2019. And that's something that we are really looking forward to having those. And in addition to the networking opportunities, we were able to provide many opportunities through the Experimental Sounding Rocket Association and Long Beach Aviation. And through these two clubs, the students were allowed to gain hands-on experience by applying what they learned in class to the projects. And it also allowed for students to volunteer for lead positions to gain leadership experience and also communication experience as well. And more info about Ezra and LBA will be talked about later in the presentation. So for our fall 2021, we had a total of about 6 speakers. Dr. Chris Ranieri of Aerospace Corporation, Bruce Benert of JPL. We had a resume workshop with Raul Pacheco of Northrop Grumman, Andy Sadwani of SpaceX. We have speakers from Relativity Space, and we also had Ian Clavio, our former CSULB AIAA chair, and he is currently working for Northrop Grumman now. And each presentation gave us a unique experience, as I said before. For example, while Dr. Ranieri was able to give us a very technical presentation about how his team was able to successfully create and execute a plan to rescue the AIAA-3 communication spacecraft. Rob Pacheco was able to host a resume workshop to present what companies look for in resumes, as well as provide us specifically with feedback. And then Ian Clavio, the former AI chair, as a recent graduate, was able to provide us with information about his college career, his job search, and his transition to the workforce. So all the speakers have been very different and very insightful, and we hope to get more guest speakers in the future to present in person. And so far for spring 2022, we had one guest speaker, and Long Beach Aviation has been hosting RC flying days and been having build days for anybody who is interested in flying or building an RC plane every Friday morning.
So in terms of outreach, we like to go to serve the local community, including elementary, middle schools, high schools, as well as community colleges. COVID-19 has made that quite difficult, but we still maintained a relationship with a lot of schools and been able to do some outreach events. Specifically, LBA has been going to Sato Academy in Long Beach, and we helped them grow the next generation of college students in aerospace engineering by building foam board airplanes, as well as doing some buddy box flying events and helping them learn to fly RC airplanes in a really stress-free way. I know when I was learning to fly, I didn't have a simulator and we didn't have a buddy box, and that was quite painful and quite upsetting to see a lot of my own RC airplanes crash. So I'm really happy to share with others a much easier way to learn with a system of 2 controllers and just bring others into the hobby and have a ton of fun doing so. So now I want to talk about our student projects. As mentioned earlier, we have the Experimental Sounding Rocket Association, or ESRA, as well as Long Beach Aviation, LBA. And you can follow us on Instagram, contact us through Discord. So let's get into it. So I'll turn it over to Sean, who's going to talk about ESRA.
So for ESRA, our general mission is to provide all the students the opportunity to research and get hands-on experience in both solid and hybrid rocket. Yeah, can I have next slide? So first we have our advisor who provide us professional insight on project development, and then we have different subsystems such as structural, recovery subsystem, and aerodynamic subsystem. So each leader is responsible for design and manufacture of a project subsystem, and then they also provide new generations with knowledge necessary for the club to continue. And all the subsystem members, they work together with all the team members to research, design, and manufacture. So for every year, we look to apply and compete in the IREC competition, Spaceport America. Also, we look to be the only hybrid rocket team on campus.
So Long Beach Aviation. Long Beach Aviation is actually the only aviation aircraft focused project group at Cal State Long Beach. We're definitely more known for our like 3 different rocket clubs. Maybe it's even 4 now. But we're pretty proud to be the only aviation and aircraft club on campus, and we get a lot of members looking to try something different. So we are also a team. We're kind of in the new, we had a very competitive and strong team last year that left. And so we're in the process of developing a new generation of LBA at the school. And so we're kind of gearing up to compete in DBF next year and put together a strong team that's very capable of building foam board RC airplanes, as well as flying. So we can have a bunch of different test pilots. And flying is also just so much fun. So in the transition back to in-person, we've been holding general body meetings. We hold seminars on Python, coding, CAD, and then some advanced aviation topics. We did a GBM talking about gyrocopters, as well as canard aircraft, because those are just quite unique and interesting to learn about. Something we also did was have a meeting on X-Flyer, which we used to do our preliminary aircraft design for design, build, fly, and one of the airplanes we're working on building at the moment. Subsystem meetings, leads work with their team on designing and building RC aircraft. As mentioned earlier, our subsystems are flight sciences, structures, as well as payload. RC flying days, this is probably the favorite and most popular event. RC flight instructors meet with members to teach fundamentals of flight and give all students learning opportunities flying RC airplanes. On the right, you can see myself with one of our members, Mark, doing the buddy box system, flying at El Dorado Park, which is really fun. And Mark was able to get some hands-on time flying and was able to do tons of laps and even figure eights all by himself within the first few minutes of flying an RC airplane, which is really cool and fun to see. So we fly most Friday mornings. When we're not flying, we're building. This was our first flying day of the year. I think we had 14 people. I don't think everyone's in the picture, but it was pretty cool. We didn't have a sign-up sheet, so it's quite overwhelming to have that many members. But luckily, everyone who wanted to got some time flying the Jelly Belly RC airplane. We also put a GoPro on it so we could get some cool first-person flying, and I'd eventually like to make it FPV so we can see what it's like to be in the pilot seat more and get a new perspective on flying RC airplanes. So thank you for listening to our presentation. Are there any questions or comments?
Thanks, Michael. And thank you, Cal State Long Beach, for the presentation. As Michael said, if there's any question or comments, drop them in the chat. But I want to congratulate you guys as well for, keeping up the involvement during this pandemic. You guys are doing great. I'm happy to see it's still going. If there are no questions in the interest of time, because we are running a little bit behind, I want to proceed to the next presentation. This is going to be Genaro from UNLV. The floor is yours.
Thank you, Luis. Can everyone hear me okay? Yes. No? Can you hear me? Hello?
Yes.
Oh, okay. Sorry. Okay. Let me share my screen. Are you able to see my presentation? No?
Yes.
Okay, perfect. Well, thank you so much for all of you guys being here and taking the time out of a Saturday. But big thanks to Luis for inviting me, Mr. Kenneth Lee. So we're the University of Nevada, Las Vegas. I think we're the David out of the Goliath of all of you schools, all the UC schools. But we're small, but we're proud. We're just going to talk about different parameters of our chapter. But my name is Genaro Marcial Lorza. I'm the UNLV AIAA chapter president, and these are my members. Let me see. Okay, so this club actually was established in 2005, so 2005, right? And it was the first aerospace aeronautics student organization. The focus was mainly on 3 objectives, and that was raising awareness and fostering the interest in the aerospace industries amongst our students. And number 2, to promote local, national, and international AIA programs. And number 3, facilitate the implementation of aerospace related projects and research, which comes naturally when you're doing these type of projects. So let's talk about our progresses. Our progress right now is our main focus for our members is the 3D printed competition, which is held at University of Texas, Austin. There's 2 sections within that competition. There's a glider and the fixed wing designs. We're kind of doing a lot of things simultaneously: preliminary research, figuring out ways to integrate structural components to our rotary and our fixed wing designs, electronic configuration, figuring out how we can control servo motors, learning about different devices or in RC planes in general. And then following the 3D printed guidelines and figure out methods that we can use to just, because the competition is essentially only using 3D printed materials. And so we have to figure out innovative ways where we can structurally implement that in our plane, so that way it can fly and perform at its best of its ability. So we have timeline to test and to rigorously work together as a team to get things done. We're proud to say that we've been first place for both sections in 2019. We sweep that out both in the longest flight duration as well as innovative design per Altair. Altair is kind of like the big sponsorship for this type of competition. And we also took second place in 2018, which I believe was the second time we competed. But our planes crashed and we have no, they were called Yetis. The fixed plane was called Yetis. All three of them crashed, so I have no good pictures currently of them. They're kind of like destroyed. So let's talk about a different project, Design, Build, Fly for 2023. I know you're probably thinking 2023. So we won 10th place for DBF 2021, but unfortunately, due to the pandemic, due to the fact that some of our like more technical sounded members left and got jobs during last year, it was really hard to register for DBF 2022. So we just didn't. So we're starting with the whole blank design. We're considering reusing 2021's DBF competition plane, which we called carbon copy because it's made out of carbon fiber material. And also it was a copy of 2020's competition Bullet Bill, which is what our plane was called. And so how are we doing this? How are we going to go about this? Because we're reinstating the program, I gave the idea to our members to try to include this in their senior design projects. I know it's similar to Capstone, but this gives us the opportunity to get some funding through the school, as well as focus solely on a project, and that way not deviate from extra stuff and taking time away from people's classes. Our senior design is already implemented as a class curriculum, divided in 2 different courses per semester, and I thought this would be a great idea. So that's probably something we'll be ramping up in the next month here. Community outreach. I noticed that some of you had that, and I think that's amazing. So our school is kind of small, and because of restrictions similar to all of you guys probably experiences, it was hard to do a lot of traditional things that we had at UNLV. One of the main traditions was introduce a kid to engineering day, which we love. We did it this 2 Saturdays ago, or this past Saturday, and it was successful. As you can see some pictures, some of the kids like learned the basics of aerodynamics and flight. And I think we inspire like future engineers, to be completely honest with you. And all of my members were present, and even our current advisor, Dr. Pusco, was there. But we also want to do after school tutoring here in Vegas. As you know, Nevada is probably like the worst in education, but that doesn't mean there's bad teachers. And there's room for growth, I think. And so we want to help our community by offering after school tutoring. We also have a wind tunnel project for future development. There's schools here in Nevada that are called magnet schools, which offer STEM related programs. So also we want to do a high school student build day. We want to use a couple of pilot schools essentially and teach them about basics of flight as well, like how we did with the K through 5th graders that came to the iKid event, and teach them how to build gliders and the basics of RC plane. Okay, so let's talk about challenges. And also, Luis, let me know if I'm running a little late or whatnot, because I know we have to all present. So like I mentioned in the beginning, the main challenges were leadership, membership, and knowledge. So there was an unestablished leadership because, like I said, there's people graduating, personal responsibilities, jobs. And so the membership automatically died. And there's also a lack of communication, and but there was an opportunity to bridge the gap, right? And I think it would be a loss that someone didn't step up. So I honestly kind of left SEDS, which is another organization. I thought, hey, I got to continue this. And so another challenge is workspace. The university has little to some interest in supporting university because they're so they have to do so much for a small school. We only have one machine shop. It's completely small. We're all tightly packed. Our planes are like, no joke, they're stacked together and like we could barely walk through there. We only had one 3D printer as of last month, but I donated my 3D printer. We bought a new one, and now we have three different 3D printers that we are able to use for our competition. So I'm very happy for that, thanks to our members. And so we were using the computer lab, and this is a picture here is where we're holding our meetings, and it's probably not the best ideal place to do it, but we had to start somewhere. So what are my plans? What are our plans as an organization? I was going to call it Project Phoenix, but I thought, no, I'm going to keep it simple and call it Liftoff Initiative. Our goals are outlined below. And our theme essentially is rebuilding UNLV AIAA through strong membership, diversity and inclusion, dedicated officers, hands-on projects, competing, because that's what leads to motivation, bonding activities with our members. That's one of the things that was lost through the pandemic because we weren't in person. Consistent meetings too. And website and feasibility access to our resources. A lot of the times clubs and organizations have this thing where they have like a niche inside Discord, and I feel like that's not beneficial for people who want to see what projects we're working on as an organization. Community outreach, like I mentioned, design, simulating, testing, and manufacturing, and fundraising, because you have to have money too. So this is a picture example of our website and what our 3D printed aircraft team kind of the people involved in it. So I do want to show off that we did launch our website. We didn't have a website for almost 17 or 14 years or 10 years, whatever time AIA was established. And I thought, there's so much content that we have, we just have to show off. So Luis, Mr. Cuevas, he's our alumni, and I had to put him in there. He's like a legend. And then there's Jet, and then there's Emma. All three work at Skunkworks. So I said, hey, I'm gonna use them as a promotion. But the theme of the website is connecting past members to new members, showcasing our accomplishments, establishing our values, and like I said, accessibility to our information, lost in Discord most of the times. And big things have small beginnings. So I think this was a small thing, and now it's growing. So a little extras. So I was part of SEDS, like I said, Students for Exploration and Development of Space. I was a project lead for SRAD, which stands for Student Research and Develop Rocket Propulsion, or at least the rocket propulsion side of it. I think UCLA mentioned this. We traditionally worked with commercial off-the-shelf motors. Obviously, there's limitations to working like that, with something like that in competitions, because you're limited to the parameters that those commercial off-the-shelf motors already come with. So we kind of ramped up the projects. We did some chemical characterization. We machined some graphite nozzles. We mixed solid propellants. We modified our horizontal test stand, working on a vertical test stand at the moment, and figured out our data acquisition system. We use LabJack software, LabVIEW. And here's a picture on the side with me showing off our horizontal test stand when we tested out in the lake bed. So the lucky thing about Nevada, living in Las Vegas, our backyard is a desert. So we can go test rockets, airplanes whenever we want. And I think we weren't taking advantage of that the first few years, but now we are. And then to the left of that image is us mixing our second batch of solid propellant that we made. And below of that, you see that a hybrid rocket that one of our senior design members did. And it was like an Iris project controlling the flow or the nozzle essentially. And right below that is a rocket competition called the Love Ship, which was implemented in 2019 by Mariana, who was our president for SEDS 2 years ago. So I just want to thank my members. I know they're watching. It stinks to you guys that you guys are growing AI UNLV, and I think this is something that we should focus, or I suggest focusing on as clubs, is bonding with your members and making sure they're appreciated, because without them, your club wouldn't exist. And I solely believe in that and have those values. So on top are the officers and below are our members. And to the side are our two advisors, Dr. Colbrith, and to the very right, Dr. Pusko, who is on this call. And I think without them, I wouldn't be as passionate about doing something so hard and so time consuming, but I'm glad we're here. And big thanks to our alumni, Jet, Awardee, and Luis Cuevas, who's on this call. And they're both awesome and very inspirational. But that's all I have for you guys. If you guys have any questions, you can check us out on our website, AIAUNLV.org. And feel free to reach out to me. I'll probably put my email on the link, and we'd be happy to work with you. I mean, like I said, the desert is our backyard, so we might have to charge you guys if you guys come here, but hey, good bonding experience, right? Thank you so much, everyone.
Thank you, Kanato. I'm glad to see that there's a plan to move forward, and it seems like you've got a good grasp on things. So thanks again for presenting, and good luck. So now I want to move forward with the next presentation, again, in the interest of time. Up next is the USC student branch. Mark, the floor is yours.
There he goes. Audio and visual okay for everyone?
Sounds good to me.
Awesome. So my name is Mark McDermott. I'm a senior representing the student branch of AIAA at the University of Southern California. So just to briefly walk through today an overview of what Viterbi is about, what opportunities we offer to our students in aerospace, and how AIAA fits in. I'll start by introducing a bit about our school. Viterbi was founded in 1905, and USC in particular is blessed to have a very strong alumni network, particularly in the Los Angeles, Las Vegas area. We like to call it the Trojan family, and it is a real thing. I can testify, and so we're very lucky to be a part of that to help us build our network in the aerospace community. One other big advantage that USC offers to its students is that there are strong opportunities for graduate school and to participate in research, both for undergraduate and graduate students, as I'll show a little bit later on. That comes both in the form of a number and wide range of research topics and fields, but also in financial support. As you can see, we were able to garner more than $200 million in total research spending. Not all of that is coming from the university, of course, but from other sources that researchers are able to procure. There's a strong financial support as well as administrative within the school to participate in new research. Another thing that we're very proud of at USC is our diversity. And one area where we've emphasized that over the past few years is bringing upwards of half of our incoming class as women, which makes for a really great and constructive engineering experience. Another thing that's been very important throughout the pandemic, but also before that, is our distance education network, or DEN, which offers online opportunities for our 400 level undergraduate courses. So ones that you would be taking in your final year, which often serve as prerequisites for graduate courses. And many graduate courses are offered in the distance education network. In fact, it's possible to obtain master's degrees from USC online. So to be able to access the quality of education that USC offers through the online platform is really nice. And what DEN allowed was for a very smooth transition through COVID, first to online teaching and then back in person, to give us that flexibility. So we've been able to keep up our level of education, I would like to think, pretty well. And then the other piece that I'll get into here shortly is our active student design teams. There are a number of opportunities, especially for undergraduate students, to get involved with hands-on practical applications to help put those theoretical skills to good use. And just as a quick note for by the numbers, we're fairly small compared to the size of USC. So we only have about 3,000 undergraduate students and a graduate population of about 6,300. And that's compared to a total undergraduate population more on the order of 20,000. So the undergraduate school is a bit smaller, and the AME department is smaller even than that. We're lucky, I didn't mention it here, that our aerospace and mechanical engineering department is separate from the astronautical engineering department. USC is one of few schools that has a dedicated astronautical engineering program. So we're able to emphasize that separately on the undergraduate and graduate levels. And of course, we offer a number of degree opportunities within each of those spheres. So with 15 undergraduate degrees and dozens of graduate programs available. A very cool graduate program that USC offers is one that I'm participating in, known as the Progressive Degree Program, which allows us to start taking graduate courses while we're still completing our undergrad. And what that means is that I'll be able to finish both in that program. You'll be able to finish both a master's and undergraduate degree in engineering fields of your choosing in 5 years or less. And so that's a great way to take advantage of all the opportunities that USC offers in one place. So one of the student design teams that I really want to emphasize for the hands-on applications is the Rocket Propulsion Lab. Some of you may have heard of us. I'd be happy to talk about it more. I'm one of the members. I'm the analysis team lead, and what we do is very much like the UCLA team. We build rockets. Our focus is on solid propulsion. That's what we've worked on since our founding in 2005. And we use an ammonium perchlorate composite propellant formulation, so APCP, just like they used on the space shuttle, a formulation that we've refined ourselves over the years. We have the altitude record for student rockets. We reached space in 2019, my freshman year, with the rocket that we called Traveler 4, across the Kármán line with a final apogee of 339,000 feet. That was launched from New Mexico in this picture that you see on the bottom right here. That was a very fun experience. And to do that, since we started in 2005, we incorporate practical skills from a wide range of technical disciplines. So we program and build our own avionics unit down to laying up the PCB boards ourselves. As I mentioned here, we lay up and machine all of our parts ourselves. So our rocket cases, for instance, are made of carbon epoxy composite. That is filament wound on a winder that we designed and built ourselves. Our ovens where we cure our composites, we designed and built ourselves. So we take great pride in having complete control over the design and manufacturing process from raw material to rocket end product. And what that allows us to do is really learn from the ground up how to go through the entire process of design, thinking about designing a part so that it can be turned on a manual lathe by our machinists and the tolerances are reasonable. And seeing the practical applications of that is something that I've found to be very valuable. It's one thing in CAD to have the perfect geometric fit, and then it's another thing to try and actually put the two parts together. And learning how to manage that is something that RPL in particular has been a great experience for. Another thing that our team does and that I'm focused on in particular is the simulation and analysis of both our overall vehicle performance and our part performance. So we have a simulations team that projects like how high the rocket will go, the distribution of possible ranges where it will land, and it helps us to do things such as sizing the nozzle, the fins, the parachute, all to help make sure that the launch is conducted safely and that we're able to recover our vehicle and obtain the data. The analysis team, which is the part that I do more for, is looking at individual part behavior. So starting from hand calculations, simple estimations to see what's going on in the system, to more advanced scripts in MATLAB that we code ourselves, to then FEA and as needed CFD analysis to get a sense of how the part is behaving and how it will respond to the loads, and to help us optimize part behavior. Currently, we're working on breaking our altitude record with a new flight vehicle in the theme of Traveler 4 with another solid rocket motor, but we're also developing a liquids program as well. We're nearly finished with our liquids test stand. That engine will be in a kerosene liquid oxygen motor. Its combustion chamber will incorporate a lot of the things that we've learned from making our nozzles from carbon phenolic composite, and so that'll be a great way for us to expand as our team grows. We now have upwards of 150 members who work on a number of different sub teams, and it's really great to see the momentum and inertia that comes from a lot of people working on something that they're passionate about. Another one of the main student design teams is the aero design team. And I want to mention this one in particular because this is the team that participates in the AIAA Design Build Fly competition that we've heard mentioned by some of the other student groups here a couple of times. Our aero design team was founded in 1991, and they've been quite successful, especially recently. In 4 out of the past 5 years, we've either won first place with our vehicle or best report, and on occasion both. And that comes from a very strong student-led team structure, much like at RPL, where there are different departments that are each led by a student. And of course, the members are welcome to go back and forth between the groups and learn as much as they can. But having students organize and lead it ourselves helps give us the experience of leading a team that's working on an aerospace problem, and how to manage that. One thing that the aero design team is particularly proud of is their Plane Tools software, which is an object-oriented program built in MATLAB that helps them to optimize their aircraft performance for each competition. They look at properties of the vehicle, such as I spent too much time at RPL. Properties of the aircraft, such as the aspect ratio, the type of propeller that's going to be used, the batteries, the effect of payload on drag, and they compute the effect of all of these on the competition score. If you're not familiar with the design build fly competition, there are usually a couple of different challenges that are scored with points for being able to do a lap in a certain amount of time, to be able to deploy a payload within a certain window or a target. And the Plane Tools software is used and tweaked each year for that particular competition to determine the optimal configuration of the aircraft to maximize score. And as with RPL, the aero design team gives its members the opportunity to experience a number of different design and manufacturing techniques. So as you can see in the vehicle on the aircraft on the lower right here, it incorporates a number of different components. There's like laser cut balsa wood in the wings. There's a composite nose cone. There's a folding propeller that's from plastic and metal. So the students, in doing this by hand, have the opportunity to work with a number of different manufacturing techniques. And analysis for aero design team is performed primarily in SolidWorks. RPL uses NX for CAD and ANSYS for analysis. We're very fortunate that the university has a site license to ANSYS, which at the academic level is provided at a significant discount rate because ANSYS does a very good job of trying to get people hooked on their software. But it's been a great opportunity to be able to get involved in that. And I'll talk a little bit more about the resources the university offers in a little bit here. But first, I want to mention the opportunities that USC offers, in particular for international students. One of my fellow board members on AIAA is from India as well, and she wrote this slide to speak to the opportunities that USC has afforded her in particular in coming from a different country. The USC has a very strong international presence, so we include students from over 135 countries around the world, and that makes up a quarter of our student population, which is excellent to bring in a diversity of perspectives. In return, we share the diverse cultural experiences that are available in Los Angeles and in Southern California. Los Angeles is an enormous city with people from around the world. And so it's a very cosmopolitan place to be able to show what America is about and how all of these other cultures can blend together. In doing so, we offer all of our student groups and research opportunities to the international students as well. Everyone is welcome to join all these clubs, including the Rocket Propulsion Lab, the Liquid Propulsion Lab, which is a graduate sort of counterpart to the Rocket Propulsion Lab. Separate organization, but related, just much more on the graduate research side. The Space Engineering Research Center, which I'll talk about a bit more later. USC Racing, which is our Formula SAE team, primarily more mechanical engineering, but still some aero components. And then of course our AIAA student branch. And then, of course, she mentioned that our networking and career fairs, also open to international students, offer specific workshops and information sessions, in particular for that community, because in aerospace in particular, especially a lot of the defense opportunities may be more restrictive or less open, and USC hosts these workshops and information sessions to help give a sense of what opportunities would be available to international students. So as far as student research goes, as I've said, the university is adamant about encouraging both graduate and undergraduate students to participate in research alongside our faculty. A great example is that Space Engineering Research Center. So this group basically builds satellites. They're also working on a lander for the moon, which I think there's a small competition going on for that to build for NASA a little autonomous lander that will go on the moon and collect data. So that's a very cool thing to work on for that. You can see in the picture on the upper right here, some members of CERC working on a unfolding CubeSat. We also recently completed the construction of our bomb family makerspace, which is an incredible area that they worked on for a little bit over a year during the pandemic, and is now open for students. And it features incredible resources. So it has this water jet, which can cut steel up to ½ an inch thick, I believe. So it's quite powerful and quite capable too. I saw the other day it cut a gearing for some servo motors that was about ½ an inch in diameter out of ½ inch thick aluminum. So it's quite capable. And it also the makerspace also includes a CNC mill and lathe to be able to precisely machine parts. And it's incredible to be able to just walk over from where we're working in the lab at RPL, the Rocket Propulsion Lab, and to go over here and get the part that we need made. We also have multiple 3D printers here of different types. And then, of course, basic hand tools and equipment. So like chop saws, band saws, drills, drill press, all the fun things for the students to come in and use as needed for their design projects and classes and for the design teams. And then lastly, I'd just like to mention our AIAA student branch. We focus, as the other organizations do, on building the professional skills of our members. So the university as a whole does a great job of bringing in the design teams and hands-on opportunities in classes. And so at AIAA, we focus on expanding the professional networks of our members. So a great example of that was in this past fall, we had an aviation safety panel featuring USC alumni who were an airline pilot and a US Forest Service director of the firefighting helicopters in the southern half of California. So those were some great perspectives in the aerospace industry to look on how engineering decisions can affect how useful the aviation product is in the long run. Other special mentions of guests whom we've had in the past are Rachel Morford, and these are all USC alumni, by the way. So that Trojan family, as I mentioned earlier, is a very, very powerful resource. Rachel Morford was the former president of the Society of Women in Engineering and is currently a director at the Aerospace Corporation. If you've heard of Relativity Space as well, Jordan Noon and Tim Ellis are both USC alumni and among some of the first members of the Rocket Propulsion Lab. Jordan Noon in particular had a big hand in designing and building our case filament winder. And then I'd also like to mention Sam Thurman, who is a manager of, who is the manager at the NASA's Jet Propulsion Laboratory of Project Support. So we had a great conversation with him about the challenges and unique considerations in managing large and long-term engineering projects. So our goals as a student branch over the next year in particular are to re-engage with members as we come out from the pandemic. Just got word yesterday that USC is, per the county guidance, removing the indoor masking mandate. So it looks like we're finally moving back towards quote unquote normalcy in our education. But of course, being remote over a year and a half, introduced, as some of the other branches mentioned, some challenges in engaging with our members. So what we'd like to do is try to expand facility tours in the Los Angeles area, which will help us to share the advantages of AIAA membership. As we all know here, that there are significant benefits through both networking and access to the research and news resources. I particularly enjoy the AIAA daily launch in my inbox during the week to keep abreast of the rapid changes that are happening in the industry, both on the aero side and on the space side. And then of course we want to leverage the Trojan family network, especially in the Los Angeles area, to show the importance of networking to our members and in building those professional contacts. So I have some of our contact information here. If you'd like to speak more with us, if you know of a facility that we could perhaps show to our members, or if you'd be interested in speaking for a particular topic to us, then please reach out. We'd be happy to hear from you. Thank you very much, everyone. I appreciate your time and look forward to staying in touch.
Thank you. Thanks, Mark. Thank you for the update. And, to kind of echo what you just said, yeah, that's kind of what my role here is within the professional section, is to be that liaison to the professional members that make up this organization. So I'd love to stay in contact with you and establish that connection there. But again, thanks for the update. Thanks for all the project updates. If anyone has any questions for Mark, please feel free to drop it in the chat now. But again, just to comment on your projects, very exciting. RPL, I know it's a lot of work to do. And I remember when I was a student and hearing what the RPL goals was just astounding to me back in the day. So glad to see that's still going. Moving forward, it's time for another speaker to take the floor. This is Dr. Melamed. He's going to give a quick intro to Aerospace Corporation and talk about planetary defense efforts. So Dr. Melamed is a project leader in the Embedded Control Systems Department in the Guidance and G&C subdivision at within Aerospace Corp, a position he has held since 2003. As a technical lead in launch vehicle software, Dr. Melamed coordinates and guides a team of interdepartmental technical experts and supports validation and mission readiness certification of the flight software and mission parameters for NASA's Artemis missions. He serves as the management, program office, customer, and contractor point of contact in the flight software area. In his work, Dr. Melamed monitors flight operations on day of launch, performs post-flight analysis, and participates in discussions concerning launch performance. During his tenure at Aerospace Corp, Dr. Melamed has demonstrated a corporate educational standard for knowledge and competency in space systems engineering. He conducts planetary defense technical and policy studies, co-chairs planetary defense conferences, serves on organizing committees, speaks at these venues, and supports science STEM events. So please join me in welcoming Dr. Melamed. The floor is yours.
Thank you. Thank you very much. Can you hear me all right?
Yes.
Okay. Thank you so much. I'm going to share my screen now. And please tell me if you can see my screen.
Yes, we can see you. I can see your screen.
Okay. Thank you so much. So thank you for the intro and thank you for a very interesting set of talks. I enjoyed the whole morning today, and I think that you are doing a very interesting set of projects. I'm going to show you where your future might be. I'm going to zip through several things here. I'm not sure if there is anyone from the aerospace HR here, so I'm going to quickly go over a set of talking points relating to what we do, and then I'm going to focus on a particular topic of planetary defense. So let me go down here. Oh, okay, it won't show very well. I had to convert it to PDF here, but I'm showing here the various things that we do, the different categories that aerospace supports, and I focused a few of the things that are related to planetary defense, which is the deflection of asteroids that might come to hit us in the future and have done in the past. So like something like remote sensing and astronomy, propulsion, aerospace engineering, orbital mechanics, and many of the other categories that aerospace is busy with. We are a very inclusive organization, and here are some of the statistics that aerospace is made out of. It's hidden here, but in circle here, I put STEM education. I'm going to talk a little bit about that. I was excited to see that part of the activities that the college students are engaged with are STEM education. I think it's really critical to inspire the next generation. I'm going to show you what I'm doing in this area. And we have very, very good working conditions, benefits. I'm sorry that some of it is clipped here. I'll have to fix it for next time. Let's see if I had, we offer medical insurance, paid leave days. We have 401k with generous contribution from aerospace. We have flexible work schedule. 980 is you get every other Friday off if you work an extra hour every day. We have a aerospace university. I'm going to zip through this just in the benefit of time here. We do offer educational assistance. So if you are planning to pursue a higher degree while work at aerospace, aerospace will fund at least part, if not all, of your academic program. And It's a very inclusive work environment. We have associations that protect every aspect of life at aerospace and every group. And we do educational outreaches in her part of our activity here. We do have internship program. So if you're interested in being intern at aerospace, this year is, I think, too late. But in the November, December timeframe is when postings will start to appear on our career page. So pay attention to it. And we are going to talk about some missions that matter. What you see here on the left is a summer intern project that was related to planetary defense. And these are some of the areas that we focus on. As you can see, they cover the whole gamut of activities that a lot of you mentioned in your talks and your activities. So if you want to pursue any of those areas, you can reach out to me. Some of the areas that are related directly to planetary defense are aerospace engineering, mechanical engineering, software and system engineering. But practically everything else here is interconnected to what we do. Here are some of our summer interns with our CEO, and this is a center where different disciplines gather together to work missions. They report that it's great fun, and we range from freshmen to PhDs. So everybody is welcome. And okay, so I think now I'm going to move forward and I'm going to zip through different areas that are related to planetary defense. NASA is obviously the main leading organization in the US for planetary defense. This is the webpage here with wealth of information about what it is, different missions that they design and send. I'm going to talk about this a little bit more. I encourage you to go and visit this webpage here. I'm not going to stay too long on it in the benefit of time. Part of NASA is a JPL center that's called CNEOS, Center of Near Earth Object Studies, which monitors what these objects are doing, what the probability of colliding with the Earth, how many of them are out there, and make predictions about the future on collisions with those objects. We are going to visit this webpage shortly, and it's a great resource to visit to learn about specific topics of planetary defense. Aerospace is part of it as well. We have created a webpage for covering certain aspects of the topic here. Part of it is teaching aids, where we develop lesson plans for high schools mostly, and engage with STEM education on this. I'm going to show in a little bit more detail on that. We also got injected into the next IMAX movie. It's called Asteroid Hunter. So when those are going to come to a IMAX theater near you, you encourage you go and see the movie, and you'll see some of us in that movie. It's been blocked by the pandemic, but it's going to come in. It's going to be released soon, I hear. We also developed a neo-deflection app. Neo-deflection is near-Earth objects, which are those asteroids and comets that could collide with us. It's an application. It's a web-based app in planetary defense. We're going to talk about in a few moments, and we are going to show how we can do competitions, an asteroid deflection competition by using that app. So if anybody wants to participate in an asteroid deflection competition, and I saw that competitions is a popular buzzword earlier in the talk, so reach out to me and we can organize an asteroid deflection competition. We also apply different techniques that helps us with discovery and characterization of those asteroids, including artificial intelligence. You can read more in this tab here. And again, I'm not going to go into it in a benefit of time. And I am encouraging you to inspire the next generation of planetary defense. I do it on my side, and this is a paper that me and my son wrote together a few years ago about the topic. If you want to read what we had to say, just go here. Going forward, so these are some of the teaching aids that we developed here at Aerospace. And you can see here there is some introduction of the apps that we developed here. You can download teaching materials that are designed for different levels of academic students, starting from middle school and high school. They are tied into the next generation of science standards. So here's a lesson plan that ties in with what the science standards define for high school level. And we factor it into those lesson plans and into the talks that I give. So anybody who has brothers or sisters or neighbors that would like to participate in some of those workshops that we hold, reach out to me. So going to the reality check around our planet. So here is the solar system. This is a picture of Ganymede, which is a Jupiter's moon, taken by one of the NASA's missions, Juno. And you can see that it is littered with impact craters. So it's not just us, it's the entire solar system that is bombarded by those objects. The moon is known to have many, many impact craters on it. I'm sure that at some point in your past, you took the telescope and looked at those craters of the moon. The moon is in our neighborhood. So we are in the same area in the solar system. Obviously, a lot of those craters are from the early times of the solar system, but these things still do happen in our time, and that could be a concern. Let me move it a little bit so I can switch to different one. So going back to the JPL website here, they have this wonderful page with fireball and bolide statistical data. And over the last 3 decades, there were about 886 entries of small objects colliding with the atmosphere and largely exploding. Some of them were quite energetic. They caused damage on the ground. We're going to talk about this one. This one is a Chelyabinsk meteor that exploded about 9 years ago over the city of Chelyabinsk. So you can go and visit here. You can zoom in into this page, read about each of these events. It has the ephemeris for some of them. So you can actually do active research on those objects and predictions, which we have done in some of our studies. There is a wonderful page that NASA put out recently, in the last 3 or 4 years, which uses those weather monitoring satellites to find information about bolides, and they are finding them in a much, much higher rate than the other type of space sensors. In the last 3 or 4 years, they already have found over 3,000 different types of explosions in the atmosphere, which means that we really live in a shooting gallery. It's uniformly distributed across the globe. There's no one area that is more attractive than any other area. And so it's really a global threat that's posed by nature. Currently, we are aware of about a couple of hundred of impact craters on the Earth. A lot of the craters are either not preserved very well or have been erased by the geological processes that occur on the Earth, but there is good evidence of some of them. The most well-known is the Chicxulub crater, or the event that caused the extinction of the dinosaurs. It occurred over the Yucatan Peninsula in northern Mexico. It's about 180 kilometer wide crater. It's not visible right now, but it has been discovered because the search for oil at the bottom of the Gulf of Mexico found those circular shapes, gravitational anomalies that can only be created by a massive impact, and it is nothing that can be created by the usual geological activities in the Earth. There were some Berkeley scientists that went down to research that, and they cut out, let's see if they have this picture here. Okay, they don't have this picture in here, but there's a lot of information about this particular event. Going forward, in our neighboring state of Arizona, there is a famous meteor crater, the world's best preserved impact crater. If you haven't visited this area, it's near the city of Flagship, and I encourage you to go visit there. If you plan a trip to the Grand Canyon, it's not very far from the Grand Canyon. I'm sure many of you either have been there or planning to go there. They have a wonderful visitor center where you can get to touch some of those meteorites and space rocks that came from space, and you get to take a walk from the visitor center into the balcony and around the edge of the crater. So it's a wonderful display of the force of nature that could happen to us in the future. Moving forward in time, this is something that I heard just recently, literally in the last couple of weeks, about a group of craters in the Estonia island of Saaremaa. Some visitor that passed by near us just told me about it, and she pointed out to this area here. So maybe one day I'll get to go visit it. I really like to go and visit those sites and read about them. So this is literally breaking news for me that I'm sharing with you. The Tunguska event is a very well-known event that occurred in the year 1908. It was an explosion of a not very, very small object in the sky over Siberia. It destroyed about 2,000 square kilometers of Siberian desert. And that is the type of devastation that could eliminate large cities around the world, like DC, Los Angeles, Paris, and so on and so forth. This is where the concern is, that those small objects are naturally very, very destructive if they were to hit in the wrong place without being prepared for it. So again, go visit this webpage here and read about everything that happened relative to this event. We now hold a yearly international event as part of an Asteroid Day organization. It's an advocate organization for planetary defense on June 30, which is the day that it actually had occurred. If you want to participate in some of our activities around June 30, reach out to Ken from AIAA. And this is a story that came recently, less than a year ago, about the Tunguska-sized airburst that destroyed a community in the Middle East area of today, in the Jordan Valley, near the Dead Sea. There was a large research team that went down there and looked at the evidence. Again, very interesting story to read. It's an area which certainly affected the communities, the ancient communities that lived there about 3,500 years ago. And they were able to find those. So this is how they think it looked before the impact, and this is how it looks today. The remnants of this city that lived there 3,500 years ago. They detected, let's see if I can find it in here, those little glassy objects that indicate that the explosion was very, very powerful, high energy and high temperature explosions that create silicate type of materials that can only be created by cosmic explosions at the time that it happened. Today we do have the means to create big explosions, but 3,500 years ago, the only explanation that we could find is an impact from space. And then 9 years ago, there was the Chelyabinsk meteor that collided the atmosphere above the city of Chelyabinsk. It was a small object, less than 20 meters in diameter, but it did injure over 1,000 people locally. And it was a wake-up call that even small objects in the range of about 18 meters can cause major damage to cities if they hit in the wrong place. This object was not discovered before its collision because it came from the direction of the sky, of the sun. And we are blinded for anything that would approach from a certain cone around the sun. Just we cannot look into that and find those dots of light in the sky that are illuminated by the light of the sky of the sun. So it was a wake-up call that we need to do something about the small objects as well, and not just from the ground, not just with optic telescopes. We have to do it also from space. So what do we do when an object like this happens to be discovered, let's say, minutes before entering into the atmosphere where we haven't done anything? So we did a study here at Aerospace with a team of some of our experts. How do we deal with that? It has been published both at NASA webinar and in a Planetary Defense Conference. And the idea here is if we were able to detect an object just about to enter the atmosphere, literally minutes, if we will let it impact just like the Chelyabinsk event, it would release its energy over maybe a major city and cause major devastation. Our idea is, can we intercept that object at a higher altitude and disrupt it and break it into smaller pieces such that the energy is diluted and saves the day over a key area? And we show that, yes, it can be done. The way we think it can be done is by use technology that we already have built to intercept our adversaries' ballistic missiles. So why not intercept asteroids and save lives rather than the other way around? So that was a study that we've done. We also ran hydrocodes to see what would happen to this object once it's intercepted with a kinetic interceptor mass of 1,000 kilograms, 5,000 kilograms, multiple of them, and some of them are with explosives. So that's some of the studies that we do here to understand how can we protect our community from these objects. So let's go back to the JPL website and see what's going on around the planet today as we speak. So I'm going to refresh it to see if anything new has been discovered, and I'm going to that. And let's see. So here is today. Today is March 5th, and we have those 4 objects that are zipping by our planet as we speak right now. Most of them are fairly small. Here is a small object that is about away from us the distance to the moon, about 1 lunar distance. If an object like this would have been colliding with our atmosphere, most likely it would have been stirred out. Here is a bit more larger object. It's about 3.5 times the distance to the moon. This is about the object. This is about the size of the object that impacted the city of Chelyabinsk. It would cause local damage, maybe a little bit of regional damage. Here's a bigger object, somewhere in the range of 20 to 30 meters, similarly, and even a slightly larger object, maybe closer to the Tunguska area. It can cause regional devastation. All of these are zipping by us as we speak right now, at just a few lunar distances away, which is considered to be very, very close approach. And then going forward, we can see that there are many, many of them that are here on this list. Most of them have been discovered this year, which means very, very short warning for anything that can be done, if at all, or some mass evacuation. If we know about it maybe a few days in advance, just imagine the panic that would have ensued if they tell you that you need to evacuate Los Angeles in a couple of weeks, right? So it's possible. Here's an object which is about 50 meters, 70 meters, and they were all discovered this year, sometimes this year in the last couple of months. So that's part of the concern. So how many are there out there? Well, as of a couple of days ago, we are aware of 28,500, and the rate of discovery is accelerating, as you can see, with more telescopes and discovery programs being put to use. You can see that the rate of discovery is accelerating, and it's a process that will definitely take a few more decades to reach out some sort of plateau of knowing that we have discovered the majority of these objects. The good news here is that the really, really big ones, the ones that are larger than a kilometer here, as you can see, the rate of discovery of those that are highlighted in red here has flattened out in the last decade or so, which means that we have discovered the majority of them. And those are the ones that can cause global devastation. None of these is not to head our way in the next century or two. So we leave it to the next generations to defend ourselves from the big ones. But those that can destroy a city or even a small country are largely unknown. We know maybe 30 or 40% of those that can destroy a large city instantly. And that's where we need to develop the next generation of planetary defenders. Some of them might be you. Every object that is discovered is put into a database that is maintained by what is known the Minor Planet Center. And you can go there and look at each and every object. You can pick out the objects that you're interested to study. You can do statistical analysis on them and everything else. So this is a nice resource to visit if you're interested in that. And what NASA is doing is, this is a mission they are designing to launch in 2026. It's an infrared sensor, which will help us finding objects like those that sneak into us from the direction of the sun, or they're just too dark or too small to discover early. So the hope is that with this mission, we'll be able to ramp up our discovery efforts and get it closer to the 90th percentile, where we will feel a little bit safer about knowing what's out there. Additionally, NASA actually have launched a mission just very recently. You may have heard about the DART mission. It's a double asteroid redirection test where they are going to deflect the moon of a binary asteroid. It's on its way to the collision with this asteroid here and its moon that's orbiting the big object. And this is a radar image of these two objects, which is very exciting. So they're going to collide a spacecraft into the moon and change the orbital period of this moon around the base one by about 10 minutes, which is something that's measurable from the Earth by looking at the reduction in the light that's coming from the main body periodically, figuring out, okay, this is the few minutes where the secondary body passed in front of the main body and blocked some of the light. So they are able to measure it from the Earth, and they will be able to see if the mission was in fact successful. So we will certainly know about it as we get closer to October, when that object will collide with when the space vehicle will collide with this secondary object. Very, very exciting. I'm really looking forward to a successful mission. Or if it is not successful, it will teach us that we still have a lot to learn about it. In order to understand, oops, I think I clicked the wrong button. Let me go back. Okay, sorry about that. Can you see my screen?
Yes.
Okay, thank you. What are we doing about it? So we are organizing international planetary defense conferences every other year, where we bring the world experts to talk about many, many aspects related to planetary defense. And it's those characterization, discoveries, deflection, disruption, mitigation campaigns. What happens if the object did impact? What sort of disaster management might be required, or preparedness? And how do we tell the public about it and try to avoid a panic or misinformation? Very relevant things to our days today. These are topics that are being discovered. What are the political and legal and social aspects are being discussed? If any of you want to be involved with those activities, you're very, very welcome. You can reach out to me. You can write papers and submit them to this conference. The next one will be held in Vienna, Austria, at the UN headquarters in 2023. We were hoping to hold the previous conference, the 2021 conference, in Vienna, but because of the pandemic, it was held virtually. We are hoping that by next springtime, it's going to be safe enough to hold it in person. And likely it's going to be held in a hybrid format where people could either attend in person or online. So this is where we are headed. You can read the final, the conference report, and you can go to the program. And so this is the final report. You can read about what we have done there, what was the nature of the conference, the exercise that we held during the conference. You can also go and listen to each and every of the talks of the days of the conference. They are fully recorded. Every presentation chart is available here. Just click on those individual sessions and you can read everything that was presented at the conference and also listen to the conference. Part of the conference was a hypothetical impact scenario. So let me go back one page here. So we have the one that we held at the conference. Recently, we also held a tabletop exercise with a similar object. What I'm going to show you here is that in the 2019 conference, there was also a comet scenario, not just an asteroid scenario, but comets can also impact us. And the problem with comets is that because they are coming from the outer region of the solar system, they are discovered very late. They come in at a very, very high speed, even relative to asteroids, and they could be very large. So a comet is a big, big challenge. So they developed a comet hypothetical. Everything here is hypothetical. So none of these are real, but they are very realistic in terms of what could happen in the future. So the problem with that is that the comet has approached from way above the ecliptic plane, which is the plane of the Earth around the sun. And we can't just send chemical rockets at that type of angle. It's just unreachable. But we found a solution. We did a little study where we thought, what if we use solar cells, tails, a new concept of solar cells to try to intercept that comet much before, when it's still in deep space. So I'm just dipping through this study that we've done a couple of years ago, 2-3 years ago, and we were able to show that by using a new concept of steerable solar veins, we're able to send the spacecraft toward the sun and then use the radiation of the sun to change the direction in such a way that we can intercept the object at several astronomical units a few months before impact. And this is a point where we can possibly do something about it, maybe just nuke it out of the sky. The system is all packed up into the launch vehicle and deploys in deep space. And I'm not going to run the simulation, but here is the simulation that we ran to show that we're able to do that and intercept the object at almost 3 astronomical units at about 3.5 months before impact, where it's safe to destroy it. So we are doing exciting studies here at Aerospace on that topic. Some of the activities that we've been doing recently is the Neo Deflection app. It's an app that we developed in collaboration with JPL, and it's intended to design an asteroid deflection mission using what is known the kinetic impact spacecraft. So we would use a launch vehicle to launch one or more spacecraft to collide with the asteroid, give it a nudge, and hopefully enough of a nudge to move it off the Earth. So you can go, it's a web-based app, nothing to download or to program. You can just click on that and the app would load onto your machine and you can go and learn about a couple of dozen of simulated objects with different orbits and try to deflect them. So this is some of my STEM contribution. Here is a talk I gave just yesterday at a local high school about this app, and we did an asteroid deflection competition in that class over about an hour. So these are the students here. I showed them a little bit of a background, and I bring with me some meteorites that I have with me to show them how they look and feel. And then we went to the app and we did a contest yesterday at the classroom with those students, which was very, very cool. This is our webpage that we developed for the app here. And if you click on that button here, it will load the app to your screen. And it's identical with the version that is on the JPL website. except that we have one additional button for teaming mode. When you turn this on, you now can go and design a mission. You can input how many launch vehicles are available to you for available types, the cost associated with those, when was the object discovered, and how many are available to launch at one particular time. What's your budget, right? We try to put some realism into a campaign. And then you'll be given maybe around 10 minutes, 5 or 10 minutes to compete against your team or your buddies to do that. And the way we do that is that we can change the mission design parameters on the panel here up on the left. The first one is the time at which our spacecraft is going to collide with the asteroid. It's default to 3 years before impact and signified by the yellow line here, D, deflection before the time of impact with the Earth, which is right there, centered. 400 days of flight time from the Earth to the object. You have to remember that the distances are vast, and it will take time for the spacecraft to be launched from the Earth and fly through space to collide with the asteroid. At this point, you see the geometry is not in our favor. We cannot launch anything. So we are going to end up with an impact in the middle of the Earth, right there. To try to change that, we should change some of those design parameters. So I'm clicking here and trying to change this. At some point, you can see that now geometry became a little bit more in our favor. And there is a transfer trajectory that was created here with the Lambert solution that connects the Earth with the object. And we were able to deflect the asteroid to another location on the Earth. Obviously, this is not acceptable. Somebody is going to complain. So we need to attempt to move it out. And let's see, how far can I go? Can I go a little bit more? Well, that's about the max. So maybe I can change the time at which I launch the spacecraft from the Earth. And if I do it just a little bit more, we still, we at the edge of this red circle here, we still end up with an impact here, but I'm going to attempt a little bit more. And I was able to deflect it just outside the atmosphere here with a very tiny miss distance of 0.024 Earth radii. And I was able to get a performance metric, a small one of 0.122, which is basically the miss distance divided by the cost of the launch vehicle. So in a competition, you will be given a much more challenging type of scenario. And your goal is to maximize that performance metric between the teams. And the highest performance metric is the winning team. If you want to participate in such a competition, reach out to me and we can organize that. It can be done virtually and in person, in the classroom. So very easy to organize. We've held several of these over the last several years. So if you want to be part of such a event, reach out to me and we can organize that. This is a paper that, again, me and my son published recently, where we looked at natural disasters as model for planetary defense planning. We looked at 3 typical natural disasters and tried to learn from them how we would engage and learn from how those events have been and are being handled today. So if you'd like to read about it, go to this webpage or reach out to me. I can send you a copy. And going back to careers, aerospace is hiring, and these are some of the career areas that we are looking for. If you feel that you belong in some of those categories, visit our website here and see what postings might be available. You can reach out to me and I can help you with some of those thinking. And I think that with that, yeah, so we are hiring. These are some of our interns from probably a couple of years ago, I'm guessing here. We did have interns visiting us last year, but they were all virtual. This summer, we'll see. I don't know. Probably some of them will be in person for sure. And if you'd like to participate in this program in 2023, then think about it near the month of November or December. And with that, I think I'm going to relinquish it back to AIAA. Thank you very much.
Thank you, Dr. Melamed, for your presentation. I know for me, at least, this talking about near Earth objects and asteroids is a difficult, bordering on uncomfortable, just because it forces you to think about where we sit on a cosmic scale and really face our own mortality. So thank you for putting into words, some of the efforts that we're undergoing.
And thank you for inviting me. Looking forward to support you in the future and shortly.
Thanks. So moving on now to our next agenda item. We have special university branch guests, for lack of a better word, Caltech. I'm going to ask that you keep your presentations within 25 minutes. So the floor is yours, Caltech.
Yeah, give us 1 second, we'll share screen. I trust everyone's seeing our presentation.
Yep, I can see it.
Cool.
All right, awesome. Thank you. We're happy to be here. We're happy to kind of show a little bit about what goes on in the Caltech branch, who we are, what we do. And yeah, let's get right into it. So we're gonna do a little bit first of branch organization, what our focus is, some events that we have done, and then we're gonna go overview into some of the technical projects that kind of are the focus of our branch. And then after that, we'll have 2 more speakers that will go way more in depth into these technical projects. So first, who we are, I'm Luis Pavan, I am the branch chair. I'm also joined here by Paulina.
Hi, I'm Paulina, I'm the branch treasurer.
Yep, and I guess.
I'll be presenting later, but I'm Malcolm, I'm the vice chair.
Yep. And yeah, the other officers are here as well. And we also have Annabelle, I don't know if you want to introduce.
Hi everyone, my name is Annabelle Gomez and I am one of the co-leads for the LIGO project.
Yep. All right. So our branch is centered across these 3 pillars. So we try to do events in all of these. Yeah, I would say maybe we're more centered on the right side. But on the side of industry, we want to connect with industry professionals and collaborate with aerospace companies, sort of to prepare the next generation of aerospace professionals. So in order to do that, we host career development workshops, we facilitate networking, and we have kind of traveled to a lot of conferences. As for our outreach side, we want to be the aerospace hub sort of in the Caltech community and bring all the aerospace professionals together in one space. And that's worked out great. We're a small school, but we already have like around 200 members in our Discord. So that's kind of nice. And we also perform outreach to sort of diffuse aerospace enthusiasm in the local Pasadena area and community. And I'll show pictures of some events we've done with the children in local schools as well. We also want to promote diversity and inclusion efforts, and we're going to be doing a joint event with B.Tech, which is the NSBE branch on campus as well. On the right side, which I said is sort of like more the main focus of our branch, we like to perform aerospace research and achieve technical excellence in order to provide students with practical project experience. So what we really focus on is very few sort of like high impact projects, and we'll show everyone a little bit of how that looks like. So some of the events on kind of like cutting across all those pillars. On the left side, we've done a Q&A with George T. Whitesides. He was the former chief space officer and CEO of Virgin Galactic. We like to do socials to build a community. We've done team dinners. We've had a talk with astronaut Benkin, who's from Caltech as well. And here on the right side, you see our outreach program where we taught a lot of young school children how to like build their own robots with kind of like different materials around the house. Like you can see some toilet paper rolls and other little motors that we had, which was a very fun event. Okay.
On the student end, we are really interested in different research projects. In our very first year as a club, excuse me, we competed in the NASA Big Idea Challenge. We were lucky to be named one of 7 finalists in this challenge. We were awarded just under $180,000 to design and develop a solution for dust mitigation to be implemented in lunar habitat environments. Our solution was HOMES, the Habitat Orientable Modular Electrodynamic Shield, which is a set of panels that can move dust across a flat surface and can be implemented inside any flat surface inside a lunar lunar habitat. Our team had about 25 members, mostly undergraduates, mostly mechanical engineers, a good distribution of different grades, grades and different majors, and it was really exciting to have this like student-oriented team. We were really just organized by ourselves. We had a lot of mentor support, and we were really grateful for that. But it was kind of fantastic to be a part of this high impact and just really involved project. We additionally had a lot of different opportunities to present. For example, we presented at the Big Idea Forum in November to a panel of judges and other schools competing in the NASA Big Idea Challenge, and also some of our members presented at AIAA SciTech in January, where we got to present to a multitude of different stakeholders. And we were really excited to get these learning opportunities and all of that.
And Malcolm will be presenting more in depth about this project right after this presentation, in case anyone wants more of the details.
This year, we returned again to the NASA Big Idea Challenge. We were lucky to be named finalists. This year, our project is Lattice, the lunar architecture for tree traversal in service of cabled exploration. And this is basically a novel locomotion modality to be implemented on the moon. We're interested in developing ways to transport a lot of different cargo or payloads up and down craters in permanently shadowed regions on the moon. The intention is that we could help support the future building of infrastructure in the future and to be implemented in the future Artemis missions. We again have a mainly undergraduate team with about 25 students. And this has been a really challenging project so far. We've been working both hybrid, some Zoom meetings, some in-person lab meetings, and currently we're in the early stages of the project. We were just awarded funding and we'll be setting up our lab soon. Really excited to see what's to come. And Lucas
Lucas will present right after Malcolm for those more curious on
the details of this project. So we're really excited about that. And I'll hand it off to Annabelle.
Hi, everyone. So like I said, my name is Annabelle Gomez, and I am the mechanical lead for our LIGO project. LIGO is the Laser Interferometer Gravitational Wave Observatory, and it's the largest one in the world. So my co-lead and I, what we do is we guide a group of about 20 undergraduates, give or take, to work with our mentor, Richard Abbott, who works at Caltech with LIGO on a variety of different projects. So one of our first projects that we're working on is a fast shutter. This project is quite important for LIGO because when in use, as you can see in the picture on the screen, the optical energy stored in the LIGO arms during normal interferometer operation is dumped into the anti-symmetric port upon loss of lock. And this energy can be of an order of about like 50 joules, which appears at the anti-symmetric port as an optical transient lasting a few tens of milliseconds. So in order to protect our sensitive photodetectors and the anti-symmetric forward beam path from damage, what we need is a shutter that's required to quickly block the laser beam upon a loss lock event. The sensitive photodetectors protected by the shutter and the shutter itself are all contained inside the LIGO ultra-high vacuum volume and are subject to extreme cleanliness requirements associated with such an environment. If we go to the next slide, you can see a general idea of what our project is. So while we're working to develop an efficient solution, previous work has shown that, and what we need is an ion beam sputtered high reflectivity mirror that we want to insert into the beam path. And this laser energy reflected from this mirror would then be directed into a specially designed high optical power beam dump. Additionally, because of this very unique environment in which this fast shutter will be located, there are a variety of requirements that must be met that we can see in further detail on the next slide. But in general, what we want to do is we need to be very careful about the materials that we pick to ensure that we keep the device small enough so that it fits in its 15 centimeter by 15 centimeter rectangle, and it has enough clearance from the laser, which is about 6 millimeters or less. Additionally, it needs to be functional enough to have an actuation time of about 2 milliseconds or less. And we need to be able to use it for 2 minutes at a time. And on top of all that, it needs to be able to have a lifespan of about 100,000 cycles of use. So overall, my team and I were very excited to face this challenge and apply our variety of skill sets to design such a prototype, and build this fast shutter. Thank you.
So yeah, that's an overview of what we do at the Caltech branch. And like I said, we're very much focused on the sort of technical or research side. And following this, we will have Malcolm, we'll have Lucas give more in-depth detail on our projects with the NASA Big Idea Challenge. But now we thought we would take like a little time to just take any questions on either the LIGO project, or so our joint work with LIGO, or sort of the other side of our branch that's more the outreach and the industry or professional development.
Hey, Luis, actually, could we proceed to Malcolm's discussion?
Absolutely, we'll proceed to Malcolm's discussion. We're ready, we'll share that in a second.
We'll hold the questions at the end for all your presentations. Thank you.
Yeah, sounds great.
Sorry, sharing screen right now.
Okay, thank you very much for joining me in this brief overview of HOMES, a project that we worked on as part of the NASA Big Idea Challenge for the past year. It was a little over a year, actually. I had the pleasure of leading that project, but you can see all of our team members listed here. So to get straight into it. So you may or may not be aware that the Apollo missions were key in identifying lunar dust as one of the most significant barriers to a sustained lunar human presence. This is because lunar dust is extremely small, sharp, and can lead to not only mechanical and electrical and optical thermal failures of systems, but also can lead to adverse health effects for astronauts, like silicosis. So it's critical that NASA develops long-lasting, highly effective, and adaptable solutions to tackle this issue of lunar dust and the moon as we go there, really starting in this next decade. So to address this problem, we created HOMES. HOMES is a series, this is, as Polina mentioned, HOMES is a series of tileable panels that leverage and expand upon electrodynamic dust shielding technology, or ES for short, that generates a traveling electric field that can move dust. Many HOMES panels can then be tiled together to actively clean off floors and workspaces or any other surfaces inside of a lunar habitat, but we hope to expand that to outside the habitat later. These panels can be connected in any planar configuration, so you can rotate them and create like essentially what you can think of as like a two-dimensional like planar conveyor belt to then collect dust in the bottom right-hand corner. You can see a collection panel that can be placed in any side of these panels or in the middle. Then astronauts can easily control all the panels just with two switches on a control unit that's simply powered by the habitat power supplies, like a wall outlet, essentially. So HOMES advances the state-of-the-art in EDS technology, and this is because it is not only modular, which is the first implementation of modular EDS, but it's also scalable. So HOMES can be scaled indefinitely as long as we have enough power from the power supply in the habitat. It's orientable, so it's rotationally symmetric in every way, as you can kind of see, and I'll talk about later in each of the corners of the panel. And it's also robust, so it can withstand the weight of an astronaut, even with a slight jump on the panel as well. It's lightweight and easy to use. So when HOMES is being used, first, it will be packaged in a habitat compartment to be shipped to the moon. Then the panels, once on the moon, can be tiled together in any configuration, as I said. Then end caps, which cover up the exposed electrical connections on the outsides of the panel, are placed. And then the control unit is finally plugged in, and then everything is ready to be used. Then everything can be disassembled and then reused again at any time. So homes can be connected without tools. As you can see here, as I'm pulling the panels apart and putting them back together. And this is because neodymium neodymium magnets are in each of these interfaces so that they self-locate in an easy way. And they have a pin slot interface to facilitate that. So here you can see a demonstration of the modularity of homes, and the dust that was placed on all of the panels then is locomoted around all three as each are oriented 90 degrees to the next, and it's collected in the collection pan. So you can imagine scaling this up to fill a whole room, and you could think of, in a matter of seconds, a whole room with moving dust could be then collected and cleaned, saving a lot of time for astronauts, which is incredibly crucial when running. So as homes is based on an intensive electrical system, we designed our mechanical support structure to make sure that the electrical system was protected as best as possible. So we have the main structure is made out of an aerospace grade plastic called PEEK, which is really strong and has low outgassing characteristics, which would allow us to shift it to vacuum environments more easily in the future. There is going from the top down, there's a PCB which has a dielectric coating on top. And that has the electrodes that generate the moving electric fields that make EDS work. Then there's a support plate below that, giving that structure that's needed to stand on. Then inside we have an internal cavity with a power supply PCB, which is vibrationally isolated to make sure that the home's panels are protected during the intense launch vibrations. And then everything else is held together with screws, and minimal adhesives is used so that if there are issues on the moon, astronauts can easily take apart and refurbish the panels. So here you can see, this is the heart of homes, the EDS PCB. So essentially, within this PCB, as you can see on the right, there are alternating sets of electrodes in sets of 4, and we send each of those electrodes 3 kilovolts, or 3.8, 4 kilovolts of current through each of them in quadrature. So it's these square waves that are offset by 90 degrees. And this EDS PCB covers the entire extent of the board so that there's no dead spots to allow for dust to collect. So here you can see we used built-in image analysis from Mathematica to quantitatively evaluate the dust effectiveness clearance of homes. 2 trials were done here. First, we had visibly coarser dust, as you can see in the top right-hand image. And we turned on homes and then took an image afterwards and compared the amount that was cleared, and the same we did with a finer dust population. And you can see the dust particle bins in each of these graphs across the particle count. And then actually in both of these, we had the outstanding result of clearing 98% of dust in just 60 seconds. And of the size range of 0 to 50 micrometers, which is the most problematic size of dust for health and mechanical thermal reasons that I mentioned earlier, we cleared 96% of dust. So really outstanding result. I'm really proud of what the team was able to accomplish here. So to complement not only the effectiveness of homes, in the EDS sense, we went through a battery of tests that were to show that it is on its way to being used on the moon. So to do this, we did high voltage testing to ensure that no dielectric breakdown would happen. We conducted over 400 hours of continuous operation of homes to show that the lifetime was sound. We applied a load of 420 newtons, or 442 newtons, and that's equivalent to an astronaut plus their suit on a panel in a 1/6 lunar gravity. We also applied an impact load and showed that Home's panels weren't degraded after that, and also did a minimum workmanship NASA standard vibration test. And so that brings us up to a TRL of 5. And that's technology readiness level. So just to sum up here, we were able to accomplish our goal of creating the first modular implementation of scalable EDS, and do so in such a way that made Homes able to clear over or around 98% of dust in 60 seconds, and we're pending TRL. So we've reached a bit of a stopping point in this project as the Big Idea project has moved on, but this is still an open area of research. There is a lot of area for future work in which we could better protect the EDS PCB, do more testing, but we could also look further into optimizing, making the panels lighter, more power efficient, and adapt it for more environments, because the same issues that are found on the moon can also be found on Mars. And so Homes could be used for Mars as well. So thank you very much. I hope that was okay on time. And if you have any questions, please reach out to me or anyone else here at Caltech, and we'd be happy to talk about this project. And of course, thank you to our mentors who we couldn't have done this project without. And I think it's time then to hand it over to Lucas. Thank you very much.
Yeah. Could you unshare, I think? Okay, also. Okay, can everybody see my screen? All good? Okay. So I'm going to tell you all a little bit about our latest ongoing project. And this one is in a certainly earlier stage of development than Homes. And you'll see it's actually quite a different project in many senses. But I hope that this background gives a hint of what we're going for. We're still working with the moon, but we have a new challenge. So as I'm sure many of you know, the Artemis program is heading to the moon, and hopefully having demonstrated the ability to stay on the moon, will show that we can head to Mars too. And so this will be over the next 3 years will be the first major step towards the Artemis program, but over the next 6 years and decade, we'll hopefully see the establishment of a gateway around the moon, so basically the next space station, as well as many rover and exploration programs and the first surface habitat on the moon. But in order to stay on the moon and stay there for a long time, you need resources. It's simply not sustainable to live off of restocks from Earth day to day. And there are many elements of what comes to making an environment livable. And some of these are mapped out here on the left. But to be clear, all it comes down to in terms of what the moon offers is volatiles that are embedded in its surface. And so how these volatiles got to the moon is occurs due to the fact that the moon's orbit and its spin is aligned with the plane of our solar system. And craters basically work out to be the perfect topological protrusion from the surface to permanently shield a region from the sun. And so by blocking the sun, they create regions of intense cold. And over the past billion years, have allowed the possibility of these volatiles, which would otherwise boil off because there's no atmosphere, to accumulate. And so therefore are very promising locations for future exploration and habitation of the moon. And so you can see some of the favorable spots on the North Pole here. But in order to do this, in order to get into these craters, you first need to get a sense of scale. And so one of the presenters previously mentioned that many of us have probably visited the Grand Canyon. Just to give you a reference point, Shackleton crater, one of the most notable craters, is effectively 5 times larger, at least in terms of diameter. And on top of that, on top of these extreme spans, there are also extreme slopes.
extreme cold, lack of power, boulder fields, and the composition of the surface regolith is actually poorly known because no one's been there yet. But there's a possibility that it could be very fluffy and hard to navigate in. Bottom line, rovers can't do this. It's simply not possible with current rover wheeled systems to navigate up and down fluffy and steep slopes beyond much more than 20 degrees. And so in order to enable the possibility of an extended stay on the moon, we need to think of something different. And so our team, this is also for the Big Idea Challenge, has looked through I think more than 80 different ideas during our idea development process. Here's a select few of some of the finer ones. But in looking through this problem and assessing sort of what we can work with and the best way to get something working soon and something that can be very useful in the long term, we had a few key realizations. One, if you're trying to get around in an extreme environment and you want to mitigate risk, prevent you don't want to fall, and you definitely don't want to lose track of your rover, you should use rope. There's a reason why in all kinds of exploration environments on the Earth, climbers use rope when getting around. If you want to climb Everest, bring a big spool of rope, right? And so that was the first lesson, and that's also great if we can figure out ways to use rope and this premise of tethers. It's great from a mass standpoint because tension loading is mechanically speaking sort of the optimal loading condition. And the second realization was, with all these uncertainties in the composition, operational interactions with the terrain that we can't really know or assess at this stage, why don't we just ignore the terrain altogether? And so that's the second element of our concept. And in these images here, I'm drawing from the fact that this is a natural solution on Earth too, particularly when trying to carry heavy loads or navigate extreme environments. And so in the past and till today, we see cable cars being a frequent solution, for instance, with shuttling logs in mountains, as well as early mining. You see these cableways very frequently occurring. And so basically what we propose is a distributed cableway system that can be deployed on the moon. And in this concept of operations for a Pathfinder mission, we propose partnering with a commercial lunar payload system that can land near a crater and effectively establish the first contact with a crater floor. And this contact is something that can be sustained into the future because our system is not only a robotic system, but it's also an infrastructure system. And so using an existing rover platform that is able to drive down a slope, because it's much easier to drive down than to drive uphill, we can deploy these suspended cables from stakes, which I'll talk a little bit more about in a moment. And along these cables, have shuttles traverse this network at not only low power cost, high speed, but also the ability to supply power along the way. And so looking into this basic premise, we've done a lot of, this hasn't been done before. And so we've done a lot of first principles analysis of the key elements that would need to make this a reality. For instance, what if we were to find that you need cable materials that simply don't exist currently? And so we've looked into many of the key aspects of this design, from the pulleys and the locomotion method for navigating the cable system, for the stakes themselves and their ability to stay anchored in the ground, as well as do so at reasonable scale and mass, and the cable's ability to withstand the tensions that we're baselining in the system. And we further, having demonstrated the basic principles, begun designing a conceptual model for how this will work and what it will look like. And so you can see here a CAD of the shuttle drawn as it traverses the cables. And you can see this is to scale, although this is foreshortened because we have effectively hundreds of meters between these stakes. And there are many scales at play here, but we use very strong Kevlar and, for instance, Kevlar and Dyneema cables that can withstand much higher tensile loads than many familiar materials, and these lightweight stakes which anchor into the ground. The premise behind the stakes is why not use something that already works? On Earth, people have the need for ground anchor all over the place. Basically, every building you're in needs ground anchoring to be constructed in the first place. And there are many other relevant applications such as power lines and pylons, where these designs have been developed over the past centuries, effectively. One particularly lightweight and promising design is the helical pile. And this is promising because on the moon, you don't have much mass, you don't have much weight to push down on, so you can't hammer something in. But the helical pile is effectively self-driving as long as you can provide a torque to it. Even more promising, there actually exists a previous student team from the 90s who began to investigate and did some testing of helical piles for the moon. And so thankfully, we're not the first. And although we'll be doing a lot of testing on this premise, there has been some initial validation to point us in that this could be a good direction. On the second hand, we need to integrate this into an effective and well-packaged system. This is a complex thing. No one's really put together something that can deploy miles of either fencing, power lines, or cableways, and all package it in under 100 kilograms on a rover. Farmers try something like this with when they set up their fences, but it's often very manual and hands-on, whereas we need to package it in something that can be well trusted and reliable. And so we've begun development of an integrated mechanical system and envisioning how exactly this is going to come together. And it appears that in the process of our development this coming year, we'll be putting together some entirely new ground anchor driving systems that have yet to exist. Oh. And then the shuttle. We've been working on designing and conceiving of a new way of self-propelling cable cars. This allows autonomy to our system, as well as distributing risk factors and enabling in the future the potential of branching and more complex coordinated behaviors. This is a conceptual and reference design that we put together for a proposal, which we'll be working to refine, as well as more complex mechanical behaviors that allow us to reliably traverse, for instance, bends in our network as we're descending and up and down the crater wall. This also allows us to take up slack and tension as the cables extend and contract due to thermal swings in the extreme environment of the moon. So the premise of this and what led us to working on this is for the Big Idea Challenge. And as part of the Big Idea Challenge, we will have our final demonstration November of this year. And that's the big goal that we're working towards. And so we're going to be doing representative environment testing of stakes in a regolith test chamber that we will be building. And this is a keystone proving point, basically, for validating the feasibility of this technology once we go to the moon. And so this will be one of the focus areas. And then the other two are integrating the staking module system, as well as developing the shuttle so that we can put it all together and come November, do a demo out in the desert. And we have also begun looking into partnering with existing rover platforms. We have Axel in mind from JPL, but there are other options that we're considering as well. And yeah, this is a picture of our team, minus 20 members who weren't able to make it to the boba session. But we've got quite a squad and a really great group of people to work with. This is a bunch of future work that I'm interested in personally, but I'm going to skip past that to the questions. I guess now we'll take questions for all the presentations.
Great job, Caltech. Wow, I'm really impressed. But yeah, as Lucas mentioned, we'll take questions for Caltech now. But I just want to say you guys sound very passionate. I can tell by the way you described your projects, and the content in here is it's just great to see from university students. So good job, everyone. Very technical. If anyone has any questions, please drop them in the chat. If not, I'd like to proceed to the career panel discussion as we're running a little bit behind, but that's okay. We'll probably have like a good 30 to 45 minutes for that discussion. I think any students that are here, it'll be a very insightful discussion about some of the things you'll think about when you take the next step, which is your career. So Ken, I'm gonna rely on you. Who do we have to support for this discussion?
Oh yeah, I mean, yes, all the panelists can turn on the camera. And students, please stay. There's a good opportunity. We have very good panelists. They're very good role models. So it's a great opportunity to listen to them and learn the career advice from them. So let me see.
Okay.
All right. So we'll bring people in. Yeah, Luis, you can continue if you like, but I'll just help you to
Okay.
get ready.
Yep, sounds good. So I know Courtney Best is here on the panel, Daniel Scalesi, myself, Dr. Melamed, Dr. Saunders, I believe, and
Dr. Garrett is here. Yeah,
Yeah,
I'm
I'm
so
here.
happy he could. Yeah, that's wonderful.
yeah, and Dr. Garrett, great. Okay, so of the people that I mentioned, I'm gonna ask each one of you to provide a quick self-introduction, no more than 3 minutes long. Just talk about yourself, a little bit about yourself, and maybe a favorite hobby. Can we start with Daniel?
Yeah, hello everybody. My name is Daniel Scalise. I am an engineer with the, actually work at USC. I work in the Aviation Safety and Security program. We are a continuing ed program that works on aviation safety, aircraft accident investigation, system safety, human factors, and that sort of thing. Most of my students are either active duty military, civilian military, airlines, rocket launch companies, etc., working professionals. And for favorite hobbies, right now it's actually, I'm writing up FOIA requests for some aircraft I have in our aircraft accident lab, trying to get the system safety documents from either the Army or the Navy, whoever answers it first. Thank you.
Okay, moving on. Courtney?
Hey everybody, I'm Courtney. Right now I'm out here in SoCal working at Boeing on satellite systems. I'm actually part of a rotation program out here, so I've worked on all different parts of the satellite. And I'm coming out of Indiana originally. I'm from Purdue University. I came here and did my graduate at USC, both in astronautical engineering. And a hobby that I like to do is snowboarding. That's what you can find me doing every weekend, basically in the winter out here.
Great. Dr. Melamed?
Hi, I've been with Aerospace for 19 years now. I was born in Jerusalem, Israel, did my undergrad at the Technion and my PhD at Georgia Tech. And I've been engaged with the topic of planetary defense really from, can I request to mute the mic on some of the other ones here? There is a lot of background.
Yeah. Okay, there we go.
Thank you. And and I became involved with the topic of planetary defense since joining Aerospace almost 19 years ago. Because what pays the bills is the Artemis program rather than planetary defense. I define defending our planet from asteroids as my hobby. So that's what I am.
Thank you. Dr. Saunders?
Yes, thank you for having me on this panel. My career is long and varied. most of it associated with the Cold War, both aerospace, bombers, and undersea warfare. About half my career was undersea warfare. So what I like to do now is schmooze with my AIAA buddies when I get the opportunity. But my real interest outside of schmoozing with my AIAA buddies is to, my study research interests are physical cosmology, which involves, for those of you who probably know what it is. And I got a strange interest in the branch of pure mathematics called the twin primes conjecture. And when I can, I work on coming to terms with that. I got ideas. I know they won't work. It's been unsolved for who knows how long. So with that, I guess we're ready to go.
Yeah, just two more self-introductions, Dr. Garrett and Ian. Can we go with Dr. Garrett first?
Yes, I think you already heard my background. Basically, I had 2 complete careers that overlapped. I got 30 years in the Air Force and 40 years at JPL. So that adds up to more than I'm old. Anyway, I'm still working part-time at JPL Consulting. I happen to program in Fortran, and all the programs for all the JPL space environment models I wrote, nobody can translate or read Fortran anymore. So I think I have permanent employment.
Job security.
And my hobby is always been, since elementary school, has been amateur telescope making and amateur astronomy. And I like to take pictures. I have all kinds of telescopes. I built all kinds of telescopes. Oh, and I was the chief optical inspector for a small telescope called Hubble, after they broke it. I followed the guy that broke it around for 3 years. Lots of fun.
Okay, last but not least, Ian.
Hello, can you guys hear me okay?
Yes.
Hi, I apologize for like the last minute joining as a panelist. I was following along with the conference today since it was really enjoyable to listen. A little bit about myself. My name is Ian Clavio. I'm working as a liaison engineer at Northrop Grumman. I graduated at Cal State Long Beach this past May with a bachelor's in aerospace engineering and minor mathematics. I was also part of the AIAA Cal State Long Beach student branch as the AIAA chair. I'm currently pursuing a master's degree, still deciding which school to go to. But yeah, that's all I know.
Thank you. Well, as you can see, our panel has varying degrees of experience. We've got early young professionals and more seasoned professionals with a lot of experience. So we've got a good mix here. I really want this panel to be a dialogue between the audience, and if you have questions, please drop them in the chat. I'll make sure to relay. But to start us off, I want to ask the panel a question. And my first question is, and this is something I've been dealing with recently, how do you deal with imposter syndrome in the workplace? Sometimes I personally get the feeling of, not necessarily being up to a certain task, a certain technical challenge, a problem. And I suffer from a real lack of confidence. And I kind of want to hear from Dr. Saunders. Have you ever experienced anything like that?
Well, sure. I think if you, I lack of confidence, I'd say I have confidence, but I sometimes have to hit the books and learn a little bit. And that's always been a challenge, but I managed to do it. And I don't know, I think lack of confidence is probably the wrong way to describe it. You just know that a lot of things you don't know. In fact, most of what's known you don't. So, you can be confident I can learn a lot of it. And so you dig in, and I think that's about all there is to that. I've got the floor here. I wanted to mention that I really enjoyed, well, number one, which I should have said earlier, to see the astounding talent that the young folks in a wide variety of stuff. My interests happen to be more theoretical, but I started out as my bachelor's degree in mechanical engineering, and got involved with aerospace, pretty early. And as far as Dr. Garrett knows, here's a book that he probably is very familiar with. Golub and Pachitov, Nearest Star. I recommend anybody that wants to know a little bit more about the sun, take a read of that. I also enjoyed hearing the student presentations. It's just, it's astounding to me. I mean, it's the talent. I think we're in pretty good shape in this country. And it's really international. I mean, we have folks from India and other places a lot. So I just want to congratulate you all for what you do. And like I said, it gives me great confidence in the future of the country. I wish I could be around to see a lot of it happen.
Thank you, Dr. Saunders. Would anyone else care to expand on the question I posed?
I think that from my perspective, those things happen to me every day now. I always have doubts when I start a new project. Am I going to be successful or not? Am I accepting too much? So my approach is to go slow, be careful, ask good questions, many questions, and get to understanding the in and out of the project before you can say something authoritative. I think it's a lifetime process to gain confidence in anything that you do, and it's not the kind of thing that will ever go away. Some people have more confidence, they jump in on big projects, sometimes they're successful, sometimes they're less. And my approach has been to go slow and learn thoroughly what I do and be able to say something about it. And that's a process that is ongoing in my day-to-day life.
I think what I've found over the years is I've been thrown in at JPL into stuff I have absolutely no idea what I was doing. I was the person in reliability engineering office who always got stuck with they need a reliability engineer, go do it. And like the Hubble Space Telescope, I'd never taken an optical course in my life, yet JPL sent me back to school to take an optical course. And then the same thing when the shuttle blew up. I don't know about you, but I had absolutely no idea about how a shuttle blows up and why I should care. And we worked it. I mean, we form a team. You try to learn. I think the one thing that I would say is never, ever fake it. That's, I think, the number one point. Yeah. Don't be an imposter. If you don't know, tell them you don't know and say you'll go find out. Yeah. I mean, that's the whole thing.
Great. Thank you, Dr. Garrett. For some of the younger professionals on this panel, any insight?
Yeah, I was just thinking, and this might apply more to people who are earlier in their career, but usually when I run into issues or problems or I don't know how to do something, there's someone who does at the company or above me who's dealt with this before. So I definitely think like being comfortable with asking for help, I think like is very valuable. I think sometimes I do get stuck in a rut of like, oh, I'm sure I can figure this out myself if I just like keep looking into it further. And eventually I just like, no, I really need to go ask someone. And so just figuring out what your network is of like who knows what and who you can go to for help when you run into something. I think that's definitely a very valuable thing to have like in the back of your mind at all times. And then on the rare occasion that you do find something that no one knows how to do, then congratulations, you get to figure it out and do some Googling. And you're going to become the expert in this. So I guess that's something that you can put in your back pocket now.
Yeah, very well said. That's so important. Just kind of knowing your network and where to obtain information, right? Yeah. Okay.
Yeah, I was in a similar situation as well. whenever there's an issue occurring in the project, I always ask the professionals in the field who have been there longer than me. As a young professional myself, I am still learning the ropes of being in the engineering company. It's a good experience to learn through, and always ask for help from any professional. If you're unsure of a problem or an issue that's occurring, you can always ask them for help anytime.
I agree with all that. And one thing I would add, especially for the students here, if you have a mentor or somebody who thinks you are good enough to do a project, believe them. Don't just assume you don't. A couple examples I had in my years here at USC, I worked with some undergrads on some like flight safety related projects, and they didn't think they could do it. I kind of had to, pull them by the teeth to get them to take on this project, and they did, and they graduated. Now they're working as flight test engineers and project safety engineers at various large manufacturers and integrators. And they probably wouldn't have had the experience to get those jobs if they hadn't taken on that project I suggested to them.
Good point, Daniel. Okay. So Kanaro here has a question. What was your approach on pulling their teeth?
I think that was just me bungling a metaphor. Basically, I had to convince him. For example, this was for a student paper competition for the International Society of Air Safety Investigators, which is a fairly small trade group, but one that USC is a member of and actually a sponsor of. And it's, write a paper about an aircraft accident investigation topic. And the rest like, oh, I don't know anything about that. Well, yes, it's a student paper. You're not supposed to be an expert. You're just supposed to read up on it. And they did. They applied. They won. They got a scholarship to go present in the Netherlands at their global conference. And now they are running a airworthiness project at Boeing Seal Beach. So,
wow.
No.
Okay. Next question. What's a skill you've learned outside of engineering that's been helpful in your career?
I can speak on that. Very recently, so I work in aviation safety, and it became clear after I got a couple of engineering degrees that airplanes don't break, people break them. So I decided to go get a psychology degree, which I recently finished, and that was wildly outside of my previous experience. And I was usually the only engineer in my classes for the psychology master's degree, and I had a lot of questions like, why would an engineer take psychology? And I was always very patient when I answered them and explained why I was there. And I think it was probably the best professional decision I've made since I finished undergrad was getting that psychology degree. I've learned so much, and if anybody has the time, I'd highly recommend it.
Public speaking. And the ability to write an English sentence. Those are the two things I just appall me about, particularly the young engineers and such.
Mm.
Yeah, writing reports is very important. Reports and papers.
And I find I spend half my time for the younger engineers correcting their English, for God's sake. It's kind of sad, and I don't know where we missed out, but I'd say that's the majority of the problem is the stringing a reasonable sentence together.
Wow. Okay.
I think that for me, it is something again that is throughout my career, and it is extending to today, is that I am surrounded by very, very capable people, experienced or not, and collaborating with those people every single day throughout many, many years. And I found that one of the most useful things that helped me throughout my career into today is to listen actively to what these people have to say, think about it, and formulate a question or restate what they say. I have found that is a huge enabler in collaborating with other capable people in creating good, effective teams. So to me, it's helping every single day in my career.
Thank you. Thank you, Dr. Melamed. For my other panelists, Courtney, Ian, any thoughts?
I feel like the one skill that is beneficial in like the engineering career is like how like the people you meet, like communication and also networking. I feel like the more people you know that are in the engineering field, the more people that they'll remember you and they will help you in your career. So, for example, I've been in contact with a couple of people like within the company to find possible rotational job opportunities that are closer to home, and I was fortunate enough to find someone that emailed me back talking about more about me and hopefully proceeding to the next level in the interview process. But also the professionals or engineers will be here to help you in your career, like to start off. Like for one, I've been helping out students with their resume reviews and give them critical feedback on what they need to adjust. So that's one thing that's pretty important.
I think, oh, go ahead.
Oh, thanks. Sorry. I think, yeah, the main thing that just comes to mind, like right off the bat, is just organization skills, I think, which is something that, I mean, you don't usually take just a specific class on. You're not like learning like in particular, but you probably are picking up in your different engineering classes as you go along, as far as undergrad. But yeah, I think that's just something that helps you get through the day and figure out like, it really helps me when I sit down and figure out like, what am I actually need to do? How long do I think it's going to take me to do those things? And can I say yes or no to these upcoming tasks? Or like, when do I think I'm going to get things finished? Like, I think that just really helps me move things along as I'm going through my career.
A good course in proposal writing would help everyone.
Yes, indeed.
So one thing that I want to say that I find myself doing early in my career without even knowing about it, but I heard this term recently, is that not everything that I attempted actually had worked for me. Many of the things that I attempted did not work, or I wasn't successful in what I was attempting to do. But I found myself that I'm doing what recently I've heard is fail forward rather than fail backward. Right? So some people fail and they give up. And I found myself not giving up, maybe taking another attempt or taking some time to think about what went wrong and how to fix it, and so on and so forth. So today, it's more of a mental thing. You know, when I attempt something that doesn't work, I say, well, how can I fail forward on it? How can I learn from it and move forward and do something that does work rather than attempt something that doesn't? So I just like this term. I think it's a good term to do.
Yeah, I'll tell you one more lesson that I had to learn outside of class, and that's on the design side, which I did some in my life, when to say no. In other words, stop, fix the design, and go into production. And that's a hard decision for a lot of engineers. They just want to keep improving it and improving it and improving it.
Sure, I agree to that. Mm-hmm.
Okay, so that's an interesting idea right there. Is the concern possibly falling into like a design by committee / just a never endless iterative approach to a problem? When do you know when to cut it off? Is it?
Well, you got to have time to produce for the next year's model. I'm thinking of the automobile industry in particular, but it's computers. It's when you're writing a paper, a report, you got to say enough. This is as far as I can get now, and I've got to get something out. And but it's hard to do that, you know, because you can always see little things that, and then you learn to write in the report future work.
At JPL, they cut off your account code.
There you go.
It's very obvious when it's time to stop.
I think this is also related to what you really want to do in your future. Do you want to be the expert that doesn't stop pursuing, you know, digging into the problem to the possible depth, or do you want to manage the project and set up the limit for, okay, that's good enough for what we need. or do you want to manage people that would execute those teams that do those projects? You need to decide what it is that you want to do. And I think the limits typically on that are set by the project manager, right? The project manager knows when is it good enough to stop and say, okay, let's move on to the next task. When is it getting to the point of diminishing return, right? So
yeah,
yeah, the experts tend to and love to dig to those problems to feed them to death. But the project manager, if you decide to be a project manager, and I've done both things, I've been both on the technical and on the project manager, I can say that it's the project manager that is responsible to make those decisions. Okay, this is good enough, let's move forward with the project, and you can bring it to success.
Yeah, I guess if I could add one thing here related to that, there's a saying that goes something like, the less you do, the less mistakes you make. So so you have a fear of making a mistake, then you're kind of hamstrung. And so the best thing to do is at some point you march on and do the best you can. Don't get overconfident and realize you don't know it all, but learn from your mistakes. When you see something really didn't work, learn from that.
Exactly, fall forward, right? Look at the mistake, think about it. What do I need to do to not repeat the same mistakes, right? And what do I need to do to build upon it and rise the level of what can I do? So I'm totally supporting what you said.
Thanks, that was great. Good insight there. So there's a question in the chat from Kamal. Good question. What skills or areas would you say would be in demand in the coming years in aerospace?
From my perspective, I would say is multi-skill. You want to be able to control those integrating environments, being agile on what you do. You don't think about a 30-year career where you will be the expert on one single thing, because it can work for you, but if something changes and it becomes obsolete, you're left with little. Versus being agile, being adaptive to the environment. And if you're adaptive to the environment, then you can tune yourself to those opportunities that come your way and be able to grab them. So being agile, I think, is the most critical thing that is required from people today. I don't think there is one single training that can be done to put you into a very long career anymore. You know, you need to learn your basics, put you on a higher level of understanding and skills and training and capability, and then apply it to whatever opportunity comes your way. Just grab it and work with it. So
you gotta go with the flow. Yeah, you got to go with the flow, because you don't know anymore. Everything is changing so dramatically. One day they're worried about the charging on a spacecraft. The next day they're worrying about oxygen erosion. They're worrying about space debris. I mean, it's just one thing after another. You have to go with the flow.
Yeah, you got to be adaptive and pick up those opportunities that come your way and work with them and then move on.
Louis, I have a couple of specific examples.
Okay.
If that helps. One on projects I've been working on, one would be AI literacy, artificial intelligence, procedure literacy. Not that you need to be an expert on it. I'm certainly not. But I did a project recently with the Army where they would be getting ground test vehicles from various companies that had some autonomous function, and the Army didn't know how to test them because, you know, you get someone drops it off and says, hey, it can drive itself through the battlefield. Go ahead and test it. And, you know, we have car companies spending billions of dollars on how to test AI, and they're still not figuring it out. So say if you have a vendor who says, hey, here's something with an AI functionality comes up to you, you need to be able to actually evaluate if their claims are true or not. And not that you have to write your own AI code, but you have to be able to know how to build a testing sandbox where to test that system before you put it on your aircraft. Because if you're a Boeing or an Airbus or a Lockheed and you put it on your aircraft and that airplane crashes, you can't just say it's the vendor's fault. It's your airplane, it's your fault if it crashes. So this gets a little bit, dealing with subcontractors. And secondly, one thing I'm seeing more and more of is cross-cultural literacy, especially if you're building something that's going to be used all over the world. One example would be if you're, say, building a turbine engine and you're writing the maintenance manual for an American audience, and then going around and then writing that maintenance manual for an Indonesian audience, even though they probably all speak English if they're working in aviation maintenance, they're going to have different assumptions and how to read things and different idioms and metaphors they use. And you can't just ship over your American manual and hope it works. You need to test it. You need to show it to them, have they read it, have they go through it, have them report any problems back to you, and be cognizant of any of those cultural differences that might come up if you're making a global product.
Okay.
Yeah, I chime in and just say like coding, just like being able to code in general. I think that's like, it tends to be a part of the curriculum a lot of times in engineering nowadays, but like, and not even just being like a hardcore computer science, like I wouldn't consider myself like a genuinely like technically good coder, but I know how to code. And I can't even like say the number of times that I've been doing something at work and it's something that they've been doing for years and years and years, and it's taking things from one spreadsheet and putting it in a different way on another spreadsheet, and it calculates these things that you then go and put it into a different tool, and then it does these things and you put it into a third tool. And I'm looking at this and I'm like, this is boring and dumb. I don't want to do this. And so I wrote something that combines all this and does it for me when I click a button. And apparently that's the greatest thing ever. And people get very excited about that. And so like just being able to like put together a code that can do things for you, to automate some certain processes that are kind of like manual and like just you don't need to be sitting there using your brain power to do these. They're just really repetitive. I think being able to write simple codes like in VBA, or just like learning some basic coding that then you can apply to all the different types. I think once you know some coding, you can figure out the rest through Google. I think that definitely helps.
Yeah.
Fortran.
Job security, right, Dr. Garrett?
I think also that you want to keep abreast of what's going on around your area continuously. Just keep yourself afresh of the latest development, because if you're talking about a long career, 30, 40 years, things are going to be different 10, 20, 30 years from now. You cannot plan out so far out in advance. You have to always keep up and learn what's the trend, what's the things that are happening, where do you want to fit yourself in when you move forward in your career. And I think it's critical to be adaptive here, to really, learn the news too. And I think somebody mentioned earlier, and maybe it was you, Courtney, that you want to network with people. Networking is critical. When you go and participate in conferences, meetings, lunch with peers is when you learn about opportunities. And, oh, wait a minute, this is a good starting point. Critical, really critical to do those networking. I think that the last 2 years showed us that this is important, those social interactions that we missed in the last couple of years, just being virtual, are important to doing things. It cannot be done online entirely. So networking, show up to events, participate in trends, keep yourself fresh of what's going on around your environment, and change courses if necessary. Be ready to change course, learn new skills. Right now it's artificial intelligence, machine learning, all of that stuff, but who knows in 5 or 10 years where things will be. It's just very hard to predict. So just be open to things that will change directions and be adaptive to those directions, and try to anticipate what you need to do to be in front of those changes, when they happen.
Okay. Yeah, and I think that goes back to what you were saying about being agile, right? With what you learn and how you conduct yourself in the workplace.
Yeah, also being agile, meaning that sometimes you really, really want to do something and either the budget isn't there or management support isn't there, something blocks you, overcome by events, who knows what, and don't get stuck, just move on, do what you can. Sometimes you can get back to things, sometimes they work later. Maybe some different people will make different decisions in future. I had this happen to me a few times where initially a no turns into maybe and then into a yes. especially when money become available. Sometimes it's enough for some person to know that you want to do something. There isn't the money right now, but in a year or 2 or 5, oh, now we have the money, we can go back to it and do it. Things like that are very possible. Just you need to listen into those opportunities and go grab them when they present themselves.
Okay. Thank you, Dr. Melamed. Next question. So what advice would you give yourself when you were in college?
Survive. When you're in college, it's down to really surviving college. It's challenging. Being in college, it is great. I mean, I've seen those projects that the students were showing, and I'm saying, fantastic. But you want to survive those things. You want to actually accomplish what you set out to do. And I think from what I've seen, there is a lot of teamwork, a lot of consulting with the experts, being mentored correctly. There are many things that should happen to do that. So yeah, go ahead. I'm sorry, I interrupted somebody.
Don't get drafted like I did.
Yeah. Well, those things that are in your control, right? And in your control you know, again, I think I cannot say enough is that just listen to what other people have to say, think about it. You don't have to accept what other people are saying or doing, but you have to listen and understand those. And then calculate your approach. You know, do you want to be part of a certain effort? Do you want to stay away from this effort? You want to wait a little bit? You know, all of these are critical skills. And I found that listening to what people have to say overcomes problems of ego, overcome problems of you're just not familiar with the topic. So give it a time to listen. And I think somebody, maybe it was Courtney as well, that said that don't be afraid to ask questions. The power of ask is tremendous. Just keep on asking questions, go to the experts that they know better than you do, and feel yourself. I'm defining myself as a perpetual student. I always learn. Every single day of my life, I learn from my colleagues, from the surroundings, from the environment. Always define yourself as a student that learns from anything that happens to you in your life. It's never too late to be a student.
I read Think and Grow Rich by Napoleon Hill. His number one advice is get people smarter than you and to help you, get a group to form around you. Number one, first thing to do, don't do it yourself. Always find people that are smarter than you.
And then one more thing that I will bring in is that, yeah, I mean, learning from people who are, I wouldn't say just smarter than you, but more experienced than you are, that have, you know, some success record behind them is critical. But another thing which I think is really, really beneficial to anybody's career is also to be a mentor to a person or to a group.
Yeah.
Go teach. If you go teach, if you show the way, it's a great learning experience for yourself as well, right? I mean, it's not just transferring your own knowledge and insights to somebody else, but it is the interaction itself is a huge learning experience. So I think mentoring, teaching, being part of a class is a humongously rewarding experience, and it only makes you stronger.
And to add on to getting advice for a college student, so I have I can imagine I have some experience with that when I was a student. So I know this happens a lot to freshmen when students join a club, they listen to what the team is doing, what projects they're doing, and then they just leave. They just come into the meeting and then leave without knowing what they gain from it. It's important for you to ask the students who are in the student team for longer that they come to help guide you in your career and also help you gain any technical skills for any software that you want to learn, whether it's from computer aided design, programming, and also you can ask the students to help you in your career, like if they have any advice as well. And it's always a good idea to self-teach a software that you may not know about. You can like ask a student lead to help you out, or maybe even a professor to help you out. I feel like if I had the chance to go back to a student and learn more technical skills, like I'm not like an expert in programming, but I wish I have more technical knowledge of it. I mean, the most basic knowledge I have with programming is taking MATLAB for a college course. So yeah, if you had the time to self-teach a software that you want to learn and implement that into your career, then I highly suggest you do that. And it'll also be good to add in your resume and talk about it whenever you apply.
Maybe I'll give an example from my own experience. My daughter is a student, undergrad student, and she is not in the technical field at all, but she volunteered to be a mentor to students that don't speak English so well, to just bring them in, to help them even know how to take their very first steps in college. And it was very rewarding for her. It boosted her confidence. It was very rewarding. And so just anything that you can do to help out other people, it's going to come back to you big time. It doesn't have to be technical. If you can teach coding skills, that's fantastic. If you can teach how to solve an equation, that's fantastic. There is a whole range of things you can do for others that will help you, build your confidence. For her, it was very, very helpful.
Yeah, I think I would add on just like finding technical projects to get involved in, I think was the one thing that helped me the most in getting ahead, I think, in college life. And it seems obvious, but like I can't stress it enough. Like it's never too early either. Like even as a freshman, just go find some clubs and find out what they're doing. If they're doing like different rocketry things or different like liquid propulsion projects or proposal writing projects or design, build, fly. I know that I was part of a few different like competition teams that were through the AIAA actually in my undergrad, and it was a direct result of being a part of those competitions and having it on my resume that I got the internships that I got at like NASA, and then I was able to use that to get my job here at Boeing. I think like it was all definitely like a whole ladder to that, and that was 100% because there was this, I don't know if they do it anymore, but it was this undergraduate space transport design competition. And that year I was a freshman, I joined the team, I knew nothing. It was a team of 10 people, but we were designing like this taxi system vehicle that's bringing things back and forth from like Lagrange points near the moon to low Earth orbit and back and forth. And it's supposed to last X number of years and all this stuff. And so we wrote a whole proposal. We placed second nationally, and then I got a call from JPL and they were like, hey, we see you worked on proposals and we have a spot opening up for an internship. Like, are you interested? And I was like, of course, yes. And it was a direct result of that. So definitely, like, you never know what's going to open doors for you. Just get involved in some stuff and have that experience, because that helps a lot. And when you go to career fairs on campus, if all you have for projects and technical things you're involved in are the same things as everyone else, like it's just not going to stand out. I know that I went back to Purdue a couple of years after I graduated and I was doing recruiting for Boeing. And if people showed up and they had on their resume, like, oh, technical projects, and they were describing the sophomore year aerospace design project that you had to do as part of the entry level like aerospace design class that everyone had to take, I was like, I'm not impressed. Like, I'm sorry, literally everyone in this line is taking this project. Like, you shouldn't have this on your resume. This isn't something that is going to stand out, at least in this environment, in a career fair at your college. So I think just like think about that and make sure that you have things that you're doing that not everyone else is doing. Get some like competition or proposal or some kind of technical project stuff on your resume.
Very good point.
And I think there is nothing like getting hands-on with actual projects, right? Either within your college or within internship settings or being part of projects. And it's part of the asking question, is there something I can get myself plugged into that actually has a budget? NASA, funds a lot of those projects within universities that they pay little sums for little projects. This is how my PhD was funded by a NASA project, and it was super helpful. And many times it takes teaming up with your professor and asking that question: do you have any projects I can get myself plugged into? Is something coming down the pipe in the next half a year or so? I mean, they would know, the professors, it's their job to know those things and give you opportunities. I'm not sure what are the other mechanisms that exist in colleges today, but inquiring what are the opportunities that are upcoming is critical, and get involved hands-on with active projects. You will be identified by customers, you will be asked questions, just like you, Courtney, was approached by JPL because they knew who Courtney is. Make yourself known. Make yourself known. Somebody is going to say, hey, that person can do that. And that's the very intent of our intern program. Our internship program is exactly intended to kind of bring those college students, team them up with experts over 2 or 3 months, and seeing who is capable, who can continue, who should we pursue, and give some additional opportunities. That's the very intent of the internship program, if you can get into one, but also being involved with projects that are simply funded by industry or by anyone who will fund a project. There's a lot of opportunities right here.
And one quick comment on internships. I think probably the best thing helped with me is I just asked one of my professors, what are some unique internships that some people don't try? Because, like the career fair, there's that line at the career fair for internships like Boeing or Lockheed Martin is long. And they told me about, at the time, was the Caltech Summer Undergraduate Research Fellowship. I saw it, I applied for it, and I got to spend 1 year at JPL and 1 year working on an aerodynamics project at the Caltech Graduate Aerospace Lab. And that was largely because I applied for it and I was able to drive up to Pasadena, meet the professor or researcher, we hit it off, and that was it. USC has something similar. Don't have to be a USC student, the Summer Undergraduate Research Experience, just, a summer research project. And another one that I'll have to pitch, NTSB has a great summer undergrad internship program that not enough people apply for. They don't get many applications for that, but it is a fantastic experience. Some of those harder to, maybe not as obvious, not as well advertised experiences that are out there. And, if you can find it and apply for it, that itself shows initiative to the people who make hiring decisions on them.
Thank you, Daniel. Yeah, internships were absolutely key, as you and Dr. Melamed mentioned.
And I'll add one more thing to that, to Daniel, is that I encourage everyone who is in college, who wants to pursue an internship position, to visit the organization's career page, not necessarily Aerospace. JPL is a wonderful open career page. Boeing, I'm sure, has a career page. Every company has a opening page. Go visit those pages on a regular basis just to learn what you're going to be asked, maybe not today, but in a year or 2 or 3, and see what's available there. So for those that are about to graduate, I think those career pages will teach you how to focus your resume, what keywords to put in your resume that will hit either the search engine or somebody who's going to be looking at your resume. See what is needed there that appeals to you, that you want to hit on an open ear, and so on and so forth. And for those that are pursuing a internship with any company, go to that company's career page, see what are the openings, and these are changing on a weekly basis. So, I mean, don't judge by what you've seen today. Go visit them every now and then, see what openings are available, and you might, I'm sure that you'll find something that will be appealing to you, and you can attempt those.
And something to add on to that, when you were looking for internships in various companies, of course, every company has a career page that is being added with multiple openings pretty much every single day. If you happen to know any recruiter or hiring manager that you're interested in to applying for a position, feel free to ask them through email, and then just tell them who you are. Maybe give like a brief introduction about yourself, and then ask any questions on how to apply and what to do next. And when you apply, of course, you have to attach your resume. If you need someone to review your resume, you can always ask someone to help you. Maybe it could be from a student or a professor or a young professional such as myself. And for me, I've been doing resume reviews as well. So if you need any resume reviews, I'm here to help you out.
And from my perspective, I'm not a hiring manager, but I know several hiring managers. So I can take your resume and put it on the desk of one of those and at least get their attention. Not guarantee for anything, but if you are pursuing or if you desire a certain position and you identify an opening that I may know they are hiring managers, then I can at least get their attention about it. Sometimes it bypass the search engine, the artificial intelligence search engine that looks at specific keywords and throw away other things that a human can detect when it reads resume.
Okay. Great. Well, I'm looking at the time and I unfortunately think we're out of it. So I'm going to have to cut our panel session there. But thank you again to all the panelists. You guys did amazing. A lot of insights from this discussion. I definitely learned a lot today since this morning. If any of you have any questions or want to get in contact with any of these panelists, please let me know. I have contact information that I can share with you. So they're definitely accessible, hopefully. But yes, this concludes our mini conference today. Thank you so much to all of our participants, all of the students. You guys did amazing. I'm very happy and very excited to see all the work that's being done. It's very, again, as I mentioned, exciting. I hope you enjoyed this event, really. I know I did. Again, thank you, everyone. Thank you for participating.
And I want to say that I enjoyed this event tremendously because this was an opportunity to actually learn about those interesting projects that are being done at those different colleges. I just had no clue that such sophisticated ideas and projects are being pursued. So it was really enlightening for me today to listen to those projects.
Luis, could are you through?
Yeah, go ahead.
I had one thing I wanted to add directly in comment on Dr. Garrett's presentation and the falling out of the satellites. And it's the principle I'm trying to illustrate is to see if there's any technical big picture that you could get. And he hinted at it when he said they put lead in uranium in the satellites. But to me, there's a big picture that you're fighting a very fundamental thing when you're doing what he's doing. I'm not talking about political big picture, I'm talking about technical big picture. And that is that if you remember from your high school solid geometry class, the volume of a sphere, as you increase it, grows as the cube of the radius, but the area grows only as the square.
Yeah.
And so you're fighting something there. When you want to get low, you got to make it heavy, or you got to lower the cross section, the area. So well, that's just it. That's the big picture to me. It's the simplest, not directly applicable at all. A sphere and the rate of growth of the volume of the sphere and the rate of growth of the area, which is more related to drag.
Well, to close out on that, one of the opposite problem is you can deploy a solar sail and get your drag so high that you come right in. And that's the other solution people are looking at, to try to get rid of this stuff.
Yeah.
Thank you. Thank you for those closing comments, Dr.
And one more thing from my side also is that if anybody wants to engage with an asteroid deflection competition, reach out to me. We can organize that. It's great fun for college students, high school students. So reach out to me. We can organize something like that. And then one more last thing is that if you do consider aerospace, be aware that aerospace only hires American citizens. So yeah, make sure that you are an American citizen if you are considering aerospace.
Great. Thank you, Dr. Melamed. Thank you to everyone. You guys did awesome. Again, this concludes our conference. Have a great rest of your day.
Thank you, AIAA.
Thank you. Thank you.
Bye.
Take care.